Welcome. Hello, hello. We are live. I did not get an announcement ready, so we are going to type this now. If you are not already, what am I doing? I can't type and talk at the same time. Okay, we're live at twitch.tv/lenser, compiler, part 52. Don't forget to at the boys. Alrighty. Announcement live. We are officially live. Welcome, welcome, everybody. Welcome to the stream. Let me make sure everybody can hear me. Okay, everybody can hear me. That's good. We are doing it. We are doing it today. More compiler stuff, as you can see by the title, and notification, as I am sure. I actually remember to change those today, so that's good. How is everybody doing? How is everybody doing? We will see. I think we'll just get right into it. And Probable Steve says, hey, what's up, Probable Steve? Thanks for tuning in. We've got a first-time chat from ZYFFXD. I'm going to call you Ziffy. If you want to be called something else, just let me know. What's up, Ziffy? What's up, Steve? How's it going, everybody? Thanks for tuning in. I appreciate you being here. We're going to work on the compiler. And specifically, I've had this in the to-do for a while. Ziffy says 4, 3. What? Is it Yush? Hi, Lance. Hi, is it Yush? How's it going? Is it really a Yush? Whoa. Okay, so to do, one of the things that's been bothering me for a while now here is we don't have like proper integer types, explicit integer types, and that's annoying. CalcMath, hello. How's it going, CalcMath? What's up? Ziffy says that's a lot of code. This is not code. Isidush says, I didn't sleep. Hell yeah. Oh man. Get some rest if you need, Isidush. I did get some sleep. I know how you feel though. Sometimes it be like that. You got this. Jackson Meza says, hi, when did you started this compiler project? Are you too advanced? I don't know what that means. First time chat from Jackson Meza. Welcome to the channel, Jackson Meza. I don't know how to say your name, but it's fun to say it. So good on you. Good name. CalcMath, it's so good to see you. Did you see the bits in the Discord, CalcMath? I put the bits in the Discord like you asked for. They're in code review. They're a little bit up now. If you want, I can reference them. Jackson Meza, when did I start this compiler project? I think like 8 or 9 months ago. CalcMath says I did see the bits. Legendary. It's really far up here now. Is it in help me? Is that why I'm freaking out? It's got to be somewhere. Yeah, here they are, the bits. He saw the bits. Ziffy says lens. What's up, Ziffy? Isidush says, nope, I missed the streams. My time zone's so bad. Rip. Jackson Meza says, oh, that's cool. I don't know what you mean by are you too advanced? CalcMath says, haven't had time to look into it deeply. That's okay, that's okay. I think it is wrong, but somehow we're getting the right answer. So, because this is the mathematically correct 48 bits that you get from multiplying these 24 bits, as far as I know. Ziffy says, I found your Discord from YouTube. I'm glad. It is a great place to be notified every time a stream happens. Oh, but this is what the computer is actually doing right now in my implementation, which does get us the correct mantissa, but we end up losing a lot of precision and bits off the top, and it's an interesting case. Is you where's Serena and Zarios Bible thumb? I don't know. They're doing something. It is like 10 in the morning for me, which means it's what? I don't even know. Probably plus 8 hours, so it's like 6 p.m. Could be eating dinner. I don't know. Ziffy says, I was trying to make a programming language. Well, I believe in you. You can. CalcMath says, yeah, that part looks correct to me. I don't know, your current code is not running into overflow, though. Yeah, I think it is running into overflow. There are bits off the top being shifted. But I am getting the correct answer in a lot of cases, so that's why it's hard to see. But I think with the bits, it's clear. Jackson Mesa says, I don't know if you've implemented many things of the compiler. I'm new, so I don't know what I missed. There's quite a bit. ZiffyXD says, this thing. Is that a smiley face? Isidiush says, it's 11 p.m. here. RIP. That's like a... What is it? That's like a 13-hour difference. That's like possibly the most different it can be. But yeah, so I want to implement all these types, but I don't want to implement like a keyword for each of these types. And I don't know if it's going to be I or S64. I kind of like the idea of S for signed and unsigned integers. Isidiush says that's opposite sides of the earth. Yeah, and we're talking. It's pretty sweet. Ziffy says, I missed 9 million lines of code being written. I don't think it's that large of a code base. We try and stay conservative. I can just use toke on source, I think. There you go. 10,000 lines of code. That's all you missed. 10,642 lines of code. How do I set up my Emacs to be as yours is? Go to my GitHub and I have an emacs.files. It's this directory structure and there's a whole thing if you read Emacs in it. It's opening because it has to load org mode. Mr. Mugabe, gotta make it 69K. We want to. I hope it stays around 10 to 15,000 lines. As for like this set of code, obviously if we add more backends, they're going to be like 5,000 more lines, I'm sure, but it's not important. What are you coding in? C. Oh, but yeah, if you check this out, you'll be able to see that there's an installation thing, and then you can install the new configuration by running this Lisp. Be sure you read it and you know what it does. It's going to ask you things. You should probably know how to answer, etc. So be sure to read through the whole thing. But this is all my literate programming. I think you can open it in GitHub and read it nicely because it's org mode. So yeah, you can check that out if you want. Set up your Emacs like this. You can also just steal my theme if you want or anything like that. Isidiush, or use LenderOS and type nano. Spoiler, it'll crash, but you get fun beat at start, so W. It wouldn't crash. It would tell you to use blaze it or type quit. Let's implement some integer types today. I think we're going to start with the parser and the AST. Just kind of go front end to back end style. So the thing I don't want to do is go to this keywords thing and say, oh, well, we have integer. Let's just add a new keyword for every integer type that we might possibly want. I want like, not that, right? So I think in the lexer, we're going to have like arbitrary. Yeah, we'll go with arbitrary int. Sure. Right? Is this fine? What? Is it part of a project lens? I forget. This is part 52. This is part 52 of a project. It's definitely part of a project. Each video is like 6 hours and there's 52 parts. It's part of the compiler project. answering for you never did the parser yet. Do you want to see like an SDL example be compiled? Is that what people are wanting? If you're not familiar, we can do something like that. It's got to be somewhere here. Oh, I even have time it going. Wonderful. Oh, what's the error? A static assert exhaust. Oh, I added a new token type without dealing with it. My bad. Beautiful stuff. Windows moment. It spends 1/10 of a second compiling and then 6 seconds printing everything out. Here we have the AST, right? A big AST for the SDL example. Then we have the IR. Here's main. Here's puts, SDL event type. We got pull event, init, quit, get error, blah, 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 right? And then we can compile this. I think I need to use the linky links. And then we can, there you go, get a little window. Are we happy? We have SDL working. We can look at the example in Intercept source code. Let me load the syntax highlighting for Emacs. Beautiful stuff. Here's the language. This is Intercept. We have SDL type declarations basically at the top and external functions. And then we just call, this doesn't need to be in this doesn't need to be in parentheses. It's just a habit from C, as you can see here. If window is equal to 0 as SDL window, this is basically null pointer. Don't worry about that. People are asking, what will the syntax look like int i32i? Oh God, no. We're gonna avoid brackets, like arrow brackets, as much as possible, I feel like. It's gonna be i32. You're gonna be able to name a function i32 if you wanted. It's not gonna be a keyword itself. It's gonna be sort of a keyword. Like it's not gonna split in the lexer as a keyword. It's gonna say if an entire identifier is equal to I followed by a number or S followed by a number, right? This would be a signed number of 32 bits wide. Yeah. Or an unsigned number of 32 bits wide, right? But if the entire identifier happens to be this thing, then we're gonna check, yes, we need that. Which may mean it's sort of a keyword, but it's not going to be parsed like a keyword, obviously, because we can't just check against a literal string. But yeah, this is the SDL example, as you can see. It just creates a window, a very basic one, and then it arrows out, and if it needs to, if the window is null. And then it says, okay, SDL initialized, enter the event loop, poll events until we get a quit event. If you know SDL, this is basically the very basic, the very minimum you need to get SDL working. And it does, as you can see by compiling and getting the SDL tutorial up and running. Poggers? Cool, that's the language. We're gonna move on. We're gonna make an example. Arbitrary arbitrary.int. That'll be fun. So what do we want? We want, okay, what do we have? So deep in the knowledge, lost track of progress, Kappa. Ziffy says blee. Mr. Mugabe says generic integer type is crazy. Ziffy says, do you do the parser yet? It does. Has HR do parser yet? You kind of can't make a language that works without a parser. That's literally the easiest step of making a compiler. It's not an easy step, but it is the easiest. What are we doing? I think I only spent like 5 episodes getting the parser going. The type checker was really quick because I just didn't type check most things. Lexer is easiest. I disagree. Personally. Lexing can get complicated quickly. Parsing is just taking, is this an identifier? Oh, If it's an identifier, check, like there's not like a complex view of it you have to have. It's just a linear stream of tokens, and the token types are all defined. It's easy. Lexing is like, yeah, we got a byte we don't know what to do with. What do you do? Okay, we got a 0. Okay, then we got a space. Then we got another 0. What is that going to be? Okay, well, how do you deal with expression separators? How do you deal with... There's so much. Comments in the lexer. You have to deal with comments in the lexer. It gets really bad. Like a C lexer dealing with the multi-line comments gets rough. Especially because of nested multi-line comments. What are we doing? Arbitrary syntax. So I'd like a U32. It's going to be an unsigned int. Sure. 69. And then I'd like an integer to be an I32 equal to 420 poggers. Yeah, this is fine. And then return. We're not going to go for arithmetic between them yet. We're just going to go for, let's use one. Return unsigned integer. Poggers. Okay, where are we at? We want to compile this basic example and see where it fails. Type integer literal is not convertible to U32. So it fails in the type checker. And it says, hey, whatever U32 is, we can't convert an integer literal into that, which is obviously wrong. But I think if we add arbitrary int, Ziffy says lexer is easiest. I built a lexer in an hour. Well, yes, you can do it quickly. That doesn't mean it's easy or the easiest part. Is it used as 420? Yes, 420. First time chat from eBird. Can I sign the integer? Yeah, well, I'll get your autograph after the stream. Oh, is it used wants your autograph too? Where is token defined? Why do we not have that here? Please don't tell me it's in. Okay, it's not in here. Where's token? Where? Okay, maybe it's. Okay, it's not here. Maybe it's in here. Okay, here it is. Jeez. So we have U64 integer. Maybe we just do something like this. I mean, the data should be able to store here. Well, we're going to need a bool, whether or not it's signed. This is going to be a struct, by the way. A bool, whether or not it's signed. Do we not include standard bool? I don't think yeah. Okay. We have bool signed. Why are you mad? Oh, because this is a keyword. So is signed. Cool. Zuraid says, yup. What's up, Zuraid? eBird says, is that a positive? Signed means it's negative, because generally if you write 42 and there's no sign, there's not a positive or a negative, right? You assume it's positive. But if there's a negative sign, aka a sign present, then it's negative. Something like that. And for this case, it's going to be an S or a U for signed or unsigned. And we're also going to need a bit width. I'm just thinking about what we need here. You can also just store an I or a U in the character of text and call it a day rather than adding an extra struct, and use integer for the bit width. Interesting, because these aren't a union. So is signed bit width. So we could store An I, okay. An S or a U, but yeah. And use integer for the bit width. It's kind of messy. I like the names, but it's fine. It doesn't matter. It's a token. In that case, we just need to go to next token. Pop on down here. Also, I got to move that for you guys. That's what I'm suggesting because that's how it's lexed. Yeah, exactly. Well, it's sort of lexed like that. I was going to have it be checked at the same time as a keyword. If it encounters an I32, then yeah. So at this point, we're going to have I32. So we need to try and parse a number after encountering S or U at the beginning of an identifier. Sure. What the... What, Dave? I don't know what you're on about. We have to say, what is text? Do we know what text is? Text is a string buffer, but I don't know if I know what that is. A string buffer is basically a vector. Okay, so we have a char pointer data. So 0 equals S, or this is probably the wrong way to do this, just so you know. Dot data. Waro. Let me get some of what she's smoking. I don't know what he's on about, to be honest. I hate parsing numbers in C. I kind of want to do it by hand and not use Strudel or something. I mean, we can just use Strudel. Strudel the turtle. Check how we parse numbers currently. I don't think it's pretty. Parse number. Where's... Okay, we have do parse number. Name char's condition base. If P last C... See, this uses the parser lexer to try and do things, which is a little worrying. This calls parse number, it seems. Does it really? Oh, Jesus. Okay, where's parse number? I searched for that and I got here, so I assume that was it. So make a 0 terminated string buffer. Convert the number. Pointer end. Okay, so we have Strudel. It is Strudled. That's good, okay. Integer literal too large. End does not equal invalid integer literal. But this isn't the case. Well, just gonna steal these. Think. It's gonna be in base 10 very much. Thank you. Lots of emojis. If you're not gonna say, if you're just gonna say random things, I'm gonna have to time you out. I don't know what you're doing, Ziffy. I don't know if you're participating in the conversation. Bit or Hugo says, the other day I was trying to manipulate bits in Python for uniwork. My God, the worst ever. I love manipulating bits. And make sure you do text data +1. Where at? Yeah, that's right here. So if it equals S or U, 0 terminate text, and then integer is equal to Strudel. Why do we 0 terminate the string? because that's where we're sturtling from. Okay. So this might get rough. No, it's fine because we're checking single. Okay, everything's fine. This will work with UTF-8. Everything's fine. Mr. Mugume says, Bit or Hugo, it's okay with NumPy, done it for my 8-bit computer. Nice. Sword says that should work, yeah. Legendary. Bit or Hugo, bits in C, yeah, pretty cool, but in Python, not so much, at least from my experience. It seems fine. I use the bit shifting and stuff in Python often if I just need to like figure out what's 34 bit shifted to the left 7 plus 8. I do that in Python because I just open up a REPL and do that. Unless I have Emacs open, which recently I discovered Ash. So I've been doing stuff like this, where you can do exactly what I just talked about, or whatever, and get 4360, right? One thing I do want to write in Emacs still to do this is to convert a number into a binary string. But that is easy. It shouldn't be too difficult. So after this, I need to check the other error. I don't need it, but I do need to check the other error. And then this one should say, I mean, I don't think anyone should ever make something that large, but I'm not going to stop them in the parser. Bit width of arbitrary integer. Bit width of integer is too large. Cool. And then in this case, we just need to break and say, oh, actually, we were kidding. So we need to say if end does equal the thing, right? Yeah. Perhaps it would be better to check for keywords first. I mean, possibly. We're just checking a single character. I don't think it's too bad. That way you could just do a break there. Interesting. That's true. That's not a bad idea. Because that would clean it up quite a bit as far as things go. Dun, dun, dun. Look in the for loop below. I think you can just go to done. Actually, no. I don't think we can just go to done. You still have to check for keywords, yeah. I think this is good. I think you were right on your first instinct was good, Sarade. Do we need to make this null? No, we're setting it in Sturtle. Okay. If end does not equal end, break. We'll say if there is a number. What does Sturtle return when there's not a number there? What does Sturtle return when there's not a number there? I might have to look that one up. I could like WSL man Sturtle. Sturtle. Is that it? Okay, where are we at? Return value. The result of the conversion, or if there is a leading minus sign, the negation of the result of the conversion represented as an unsigned value, unless the original non-negated value would overflow in the latter case. Okay, legendary. The resulting value is out of range. The given base contains an unsupported value, not in C99. Even may say error note to inval in case no conversion, no digit seen, and 0 return. So we need to check for e inval, it looks like. eBird says, so what are we doing, Radica20 Cheese? We're implementing arbitrary sized integers. So you can just do like a 32-bit width integer instead of currently, we just have like the integer keyword and it's an 8-bit signed integer. So I'd like some more flexibility here. So it says, no, we don't look at the second check. It checks where strudel stopped. But it doesn't write anything necessarily to end, does it? What does it say? If endputter is not null, strudel stores the address of the first invalid character in endputter. If there were no digits at all, strudel stores the original value of inputter in endputter. strudel stores the original value of inputter in endputter and returns 0. In particular, and return the entire string is valid. Okay. Okay. So basically, if it's at the end, it's got to be a valid string. Yeah. Yeah. Okay. So if there's not one, so we need to check that it's longer than a size 1. That's why I'm freaking out here. Because if just S or just U isn't anything, but this, because it's longer than 1, it means that the null terminator we add will be able to, yeah. Okay. I feel better about that. He says language equals new language. Jesus, in like JavaScript syntax. Maybe C++ syntax, but it doesn't look like C++. So it says, sure, yeah, but I'm pretty sure that's the only check that was missing. Legendary. So at this point, we just need to actually create the token. And we already set integer to the bit width. So we need to say text dot, I can just shrink this. Is there a string? There's no string shrink, so I'm just, or resize, so I'm just going to use this. Isidius says, tokenizing is hard. Yeah, welcome to lexing. Remember when I said parsing was easier than lexing? I was not kidding. You just need to set the token type, that's it. I think we do that here. And then we break. Do I need to go to done? What does done do? Break is probably the same thing out of this switch. I think break is fine. It doesn't matter if there's junk left in text so long as the first char is S or U. Interesting. Okay. That's a good point. Yeah, that's fine. That's fine to hold until parsing. Well, in this case, can we parse? Whoops. Can we parse something? Exhaustive handling of token types in token type to string conversion, error.h 4730. 47. Oh, that's literally just the definition of static assert. Where is it defined? In expansion of macro 1499 in parser.c. Okay. Legendary. It's now 49. And token 4. We now have a new... Arbitrary int. It's not necessarily ideal, but we should never hopefully see this. I think we do this same thing with integer literals. How are integer literals printed out? I don't see those here. I guess it's just a token type. Yeah, it seems fine. We can't see the error messages if that isn't intentional, by the way. Thank you. I was just switching and checking really fast. I didn't think it mattered. But yeah, they're just here. Integer literals are token number. They're not, okay, yeah, okay, it just says number. Okay, well, I'm just gonna go arbitrary int. I don't really care. That's fine. Well, that's that static assert handled. Give me another. Expected base type got arbitrary integer. Cool, that's perfect. So now, this is an error message from our parser that we can look up. Expected base type got blah. Hey, look, it's right here. And it's the only one, pog. There is no token integer, and that's on purpose. Legendary. eBird says, okay, eBird, I'm pretty sure I went to school and all, but like, what project is this? Or just some exercise in some language? If I may disrupt. Yeah, there's no problem. I showed a little bit earlier. This is a language I made up. Go to my YouTube, you can see all 50 videos of me developing this compiler. They're each like 6 hours long, so there's plenty for you to watch if you enjoy this type of content. Yeah? This is the language I made. It's called Intercept. Saraid has so generously helped out very often and made his mark on this language as well, and is just a constant great person. We have him on the podcast all the time. The stream. This isn't a podcast. Oh my god. Please never let me start a podcast. I should never talk that much. This is a language I came up with, and then Saraid has helped amazingly in development, push it forward, as well as keep me motivated by just inspiring me and making awesome things as he does. He works super fast. Anyway, it's just a language. I'm working on it. This is an SDL example. We can look at a simpler example like greatest common denominator. So for example, you can define a function, right, with a return type, and it has parameters like a and b, optional comma. And you can say if a equals b, return a, else if a is less than b, it returns GCD Euclid of a, b minus a, and else GCD Euclid a minus b, b. If you're not aware, this is the Euclid method for determining the greatest common denominator of any integer. So this is just a little view into the language. The last expression in a block will be the return value of that block, because a block is also an expression. Everything in Intercept is an expression, except for types, but that'll be changing soon, I'm sure. This language has kind of a limitation right now where we only have integer. We have byte, right? We have an unsigned byte, and then we have a signed 8 byte integer, right? And I have to-dos everywhere and say like, oh, this is supposed to be 4 byte signed, this is supposed to be 4 byte unsigned, this is supposed to be integer type fix up, because they're all wrong, right? So it's like, for interoperability, you really need to know the explicit sizes of things. And for that, it's kind of required to be able to explicitly size your integers. So to explicitly size the integers, we are now, hopefully, parsing. I think if I do, correct me if I'm wrong, dash syntax only, we should be able to see, nope, the parser is failing still, that's right. So we can't parse it yet, but we are lexing arbitrary integers, as you can see. We get an arbitrary integer token, but we don't know what to do with it. So expected base type. This is within the function, where is this? Blah, 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 blah. Parse type. So we're trying to parse a type right now, and we're getting this token. See, we handle left parens, identifiers, ampersands, void, byte, integer. So it seems like right in here would be the place to do things. And if we can do an arbitrary int here, I don't have standard print. This is not Lenser OS. we can print out got arbitrary integer signed equals blah and width equals blah. Trying to think, is it z? And then this is going to be whether or not the token at 0 equals s or u, right? So if it equals s, then this might be a little easier to do on a separate line, just for fun. Is signed equals false. If the first one is s, is signed equals true. Don't even need this type of thing. And in fact, we can just have it equal to this. Nice, yeah. And then we can have it signed, and then the bit width is just going to be the token integer. Oops. Expected brace, but got equals. Ah, yes, yes. So it's saying that I did not properly is singed. Singed. I can't even read. Pog. Okay, this is going better. Didn't put a new line, but it's going better. You also forgot a break. Is that what's going on? That's definitely what's going on. That makes more sense. This is much better. Okay, what do we have? Also, for completeness sake, if you haven't already done that, maybe add arbitrary integer or something like that to both the grammar and the comment above parse type. It doesn't need to be any more specific than that because it's a terminal, i.e. a token. I see what you're saying. Yeah, that's probably a good idea. Archetypio says, looks nice. Building parsers is so much fun. Everything is so transparently deterministic. It's true. It's all just very like, if this, do that, if this, do that. It's very nice. It's satisfying. Sorry, it is singed. Can't believe I can't read. So we got an arbitrary integer, as you can see, when we're trying to parse a type expression. And it's not signed, and we got a width of 32, so this is U32. Whoops. And if we look at our IRC window instead of a webcam 5 head, a bit 69 stream. Good name, good name. Next generation VTuber. Oh, you know it. I don't even know what that means. What is a VTuber? Cool. Arbitrary int. Okay, and then we can go to the grammar and do basically the same thing. We should probably just copy this. That seems better. Like when you have a digital avatar instead of your own face. Oh man. Okay. Oh man. Bidor, Hugo, Archetypio, eBird, and MJPTV, thank you so much for the follows. I appreciate it so much. I appreciate you all for watching. Hope you're having a fun time. Nashiora says, I have arrived. Hello, Lens. Hello, Nashiora. Okay. Updated the grammar. For a second, I hit my desk there a little, and the monitor was like shaking back and forth, and I was like, oh no, that's gonna like be bad for the stream. It's like, I didn't want your screen to shake, and then I realized how dumb that was. So we need to set out to some sort of type, because currently it's going very bad. is what it feels like is happening. That's better. So you can see I32, it just thinks is a named type, and since we never use it, it's like, yeah, sure, fine. Legendary. So how does it get the type of I32? Where did that come from? It's a little scary. I don't have I32. Oh well, it's fine. What are we doing? So basically we need to set the type to some sort of type kind. So it's going to be a type primitive, I guess. Maybe check type name. I don't know where that is. It's probably in like ast.c or something. So we switch on type kind with the default being unknown. I don't know what's happening there. I'd make this its own kind, i.e. type integer. You don't think it should be like a primitive? I mean, that's fine. It doesn't have to be. I'm just curious. It seems like we could fit it, like construct a primitive type. No, I don't think so. Okay. Because it seems like we have like a primitive has a size, an alignment, a name, and whether or not it's signed. These are kind of everything we need. Primitive types are all hard-coded, basically. Interesting. So you want to keep primitive for like the statics and the pointer comparisons. Integer types you can now have an arbitrary number of. I see what you're saying. I mean, that's kind of okay. Yeah, I think it makes sense. It's definitely not crazy. Type integer. It's going to be kind of annoying, I will admit. Type kind. Make type integer. I don't know, maybe it'll be nice to have all of the facilities for it separate. Location, we're gonna have a bool is signed. We can have horrible indentation happening, that's fun. And then we have the probably usize bit width. Okie dokes. Create a new struct type. Yep, thanks for the terrible indentation, I appreciate it. Ah, you agree. Wonderful. What are you mad about? Why is this mad? Am I crazy? What is the error? Non-void function does not return a value. Oh, Jesus. So this type, we're going to want, yeah, we're going to have to do something about that. Okay, what's happening? They're similar but not quite the same. For instance, integer types don't have a name. That's a good point. This might also make handling integer-specific operations and semantic analysis easier. Also, this is going to be the fun part. Everything that assumes that the size is in bytes will have to be rewritten to now accept a size in bits goal. You say that, but we don't have to do that yet. I have plans. Which language server do you use for C++ on Windows and Emacs? ClangD, as far as I know. Yep, it's ClangD. Sir Aid is correct. It's the Klangmeister. I don't remember how to look at that. Yeah, here, I can look at C mode. Oh, it's beautiful. It's natively compiled. No, bytecode compiled. poggers. But yeah, it's ClangD for tree sitters, as you can see. That's crazy these are compiled. Why are these compiled functions? I'm kind of curious now. What does this do? It just tries to use ClangD or CCLS. Okay, there you go. So it's just the default. Built into Egglet. It's built into Egglet. That's why it's compiled. Okay. Pog, Emacs with tree sitter support. Yep, my language highlighting is done entirely by tree sitter. This is a tree sitter mode. Type integer. Is singed. We have usize, bit width. Push QRDX says, did you manually install ClangD and Egglet and it works? Egglet comes with Emacs. I meant ClangD itself. Egglet and TreeSitter both are built in. TreeSitter isn't built in, but TreeSitter integration is built in. It depends on how you think about that. Bit69stream says, it comes with Clang as far as I know. Yeah, I'm pretty sure I just pointed it at like MSVC ClangD. I didn't install it. I'm pretty sure it's MSVC, like whatever gets installed with Visual Studio, as far as I can tell. Type integer, we have is signed and bit width. I think that's all we'll ever need. So when we're constructing this thing, we can say type integer bit width equals bit width. Type integer is singed equals is singed. Beautiful stuff. Yes, yes. Now, out does not equal t void. Out equals ast. Make type integer. Wait, so you do have Clang for Visual Studio installed? I don't think so. It would be in my path if it was, because ClangD is in my path. I don't know. I put ClangD in my path. I don't think I think ClangD is used no matter what as a language server for Visual Studio. Or I have Clang somewhere for MSVC and it just doesn't work and is not connected to MSVC anymore. It's not connected to Visual Studio. All I know is that it doesn't work. I mean, this Clang sort of works most of the time. But it's a POSIX model. And not installed for MSVC. And the ClangD doesn't work. So this is the AST that you need. This is the, what am I passing here? Source location. I think that would be the token. Source location. And then we're going to have is singed and the bit width. We don't need all this fanciness. We'll keep is signed just for readability, just to know what the hell's going on. Okay, let's figure out how much this breaks. I think he means how did you install Clang just through Visual Studio Installer? No, it's a whole thing. It's a whole thing. Exhaustive handling of all type kinds in AST.C 515. So type count is now equal to 8. And we're going to say I guess this is done in a different style. Format to string. Kind of sucks that we only have strings here. Is there a way to append characters? Format to just take strings. Wonderful. That's annoying. So we're going to have to do something like this. If type integer is signed format to s, else format to su, format to s, percentage. What is this going to be? This is going to be a format specifier for an unsigned size typed integer, so that should be z. Okay. Sure. I could probably do a ternary thing here. That's cursed. Is that allowed? That's some syntax right there. Just do format to C is signed SU bit width. Why not just this? I don't think that'll work, by the way. It won't compile. It's just, it's messy. Yeah, I have to do percentage %s and this thing. Percentage %z, not percentage %s, but you know what I mean. Yeah, I got you, I got you. Integer is signed, then do S or U, and then do the bit width. Coolio. What else do we have? I guess they're all still here. AST 609. Okay. 609 says type size of. Okay, here we go. Case type integer. Return type integer dot bit width. Now we're going to align this to the next largest multiple of 8. Yeah? And to do that, I think we're going to have to add a number to it that possibly may be 0. And it's going to be bit width modulo 8. But it's going to be 8 minus that, I think. So we have some bit width, let's say it's like 57, right? 57 modulo 8 is 1. So we don't want to add that. We want to add 8 minus 8 modulo 8, which has to be 1 through, see, I don't know if that's right, because then this means this can never be 0, and we definitely want it to be able to be 0. For aligning, please check the code where we align structs, because it's so easy to get that stuff wrong. That's not a bad idea. I think it's this thing. Yeah, it's this thing. Let's just put it here and break it down, right? Aligned value plus equals, so unaligned value plus equals alignment. That's going to be 8 for us. Oh, there's another one. And then byte size is going to be unaligned value. And this is equal to the aligned value. And 8 is obviously the alignment. So we're going to take the bit width, the unaligned value. We're going to add the alignment. This is why modulo alignment is needed at the end. This 8 minus 1 thing I was thinking about. So 8 minus the unaligned value, modulo 8, and then all of that, modulo 8 in its own thing. That's not in the right spot. That spot. Why mad? What's happening? Oh, there needs to be another one around here. Why are you mad? Expected expression? I think Egglet is freaking out. We're gonna do a little reset. Okay, you feeling better, Egglet? You're feeling better. In general, padding equals line minus size per modulo align, which is fairly unintuitive. Very, yeah. We should probably just make this a function somewhere. So we have type integer, which now is its size in bytes. And then to do, consider this returning bits instead of bytes. I think this is fair, right? At some point, we should probably handle bits. We can put it in utils.h, utils.c. That's a good idea. Let's just do that. Dun dun. And then this is just going to be usize. I guess it doesn't even need to be a function. It could just be a thing like this. And it's just going to be value minus, not value, alignment, minus value modulo alignment. In that case, it should be aligned to. Good point. Align to, which is alignment, value, alignment. Otherwise, we could end up evaluating stuff twice on accident. That'd be fun. And then it's actually going to be value plus this, right? It's going to be value plus alignment, blah, blah, blah. This is how to get the offset that we need. And then this is how to get the thing. Okie doke. Align to 8, I think. And also, in case you're forgetting about it, the chat box is blocking some stuff when the lines get long. Thank you. I forgot to get my little thing up today. I'll do my little blocker. That'll help me out. Thanks for the reminder. King Buns, make it line wrap more, hee hee. So we're gonna align this to 8, and then we're going to divide by 8. That way, for example, if it's 57, gets 64, 8. So we need 8 bytes to store 57 bits, which is correct. I'd rather not see the code than look at line wrapped code. Lol. Okay, case. Type integer. This is going to be another align to scenario. Sure. Type align of, type size. But the align, is that what it is for integers generally? It's the same size as the integer. I don't see why we would need a larger alignment. For an unnamed type. Yeah, that should be fine. So that's aligned to, as you can see. Beautiful, beautiful. That'll be a nice utility. We can even go replace the type checker alignment with this stuff. Right? And then T structure byte size. That should be equal, as far as I know. We can, I guess, check by doing something like this. It's a little unorthodox, but egglet should give us... Okay, no. Can you spawn an egglet? Thank you. Can you give us some actions? You can. Okay, T structure byte size equals T structure byte size plus T structure alignment minus T structure alignment, yeah, T structure alignment minus byte size modulo alignment modulo alignment. Okay, I think that's equal. Poggers. Why are you mad? Did you mean this line to be inside this if? No. I think that's good. And I think we can do the same thing here. Where we add the alignment to that. Can I do the same old check? No reason not to. Byte size plus alignment minus, yeah, let's just, it's literally exact. Poggers. Okay. I think that's much better. It's at least more readable. And compiles to the same thing. King Buns. Bog champ. Oh, sorry, it said line 716 too. Yeah, legendary. Legendary. What else do we have going on? Not Clang version. What else do we have going on in errors? We don't. Terrifying. Okay. There's no errors. Oh boy. No, the reason for this is because I did syntax only. So this just means we're parsing it. This is when type checking will happen. Yeah, okay. What do we have here? This is not readable. Not very well. Okay, so we have an ICE invalid type kind of type U32. Okay. This is in the type checker at 676. This might be in type checking types themselves. 676. Yeah, this is in type checking types. So when we type check a type itself to make sure it's correct, there are some things we want to ensure about an integer, right? There are some very large deals that we need to handle. Is this... What happened? What? Okay, each of them returns. That's a little confusing. That's fine, though. Where does this end, then? So after this return should be the next case? This is not formatted properly, I don't think. Let's add some new lines so this is readable, huh? I think that's a little better. The primitives and these are simple enough, but these all being next to each other kind of hurt me internally. Now we have a case integer. And really, one of the biggest things that we want to make a big deal about... Is this an invisible error? No, because it's calling type check type. Okay, we need to do something like this. And we need to do if not t integer dot startup company dot bit width. And we can say error rejecting arbitrary integer with 0 of 0 width. Sure. Yeah, like check that it's not an S0 or something like that. Well, exactly. Pretty much. Okay, what else? What do we got now? Internal compiler error unreachable. It might be important to return true here. Turns out. Who knew? Okay, very good. Now it says type integer literal is not convertible to U32. And this is going to be a simple check, because I'm pretty sure type is integer. We just need to check that t is equal to, right? We need to check or t may be equal to an integer type. Interesting. Yes, that makes sense, because that's not the correct thing. Anybody notice that? That's supposed to be an S. Poggers. Chat, look, we did it. We have an unsigned 32-bit integer. We have a signed 32-bit integer. And everything's going fine. So it says this is going to go horribly wrong because it assumes that every integer type is a type primitive, which is no longer the case. I mean, it's not going to be that bad, I don't think. I'm just trying to figure out where do we actually use type as integer in a way that matters. So if they're both left-hand side and right-hand side are integers, here, just for use rate, I'll turn this off. If both the left-hand side and right-hand side are integers, we do assume that they are literals. Right-hand side literal dot type. But that's only if right-hand side equals a node literal. So we are checking for that first. And then we say else handle binary operator with types. Am I crazy? And this is only for shift left. Yeah, this isn't related. That's not related at all. I can keep going in my little search here. Nothing there. I don't think we're using it in that same way anymore, Sarade. I'm not seeing... Here it is. Here's where it's going to be a problem. So I believe it's checking primitive.size. Wait, go one back. Here? It's also here, you're right. You were going too fast. I think this is fine. So we have 2 as int. Oh, and then we're saying if they're both ints, we're assuming they're things. This is fine. Yeah, this is fine. Probably should have been doing this anyway, really. Two is signed is going to be a more difficult one. We're going to say if what is this? This is going to be a type. It's a primitive, not a pointer, a primitive. And that's going to have an unsigned. Okay. I could just do like this. Seems kind of messy. What's a better way? Else unreachable. Handle integer type. In where even is this, by the way? In convertible. When getting convertible score. Percentage T2. I think that's reasonable. If you're already going to put assert 0 there, then that basically means unreachable. And type is signed canon. We could also add type is signed and type is signed canon. So we could call type is integer on something. And then we could call type is signed on that integer something. And then we could call type is, yeah, I don't know. That seems fine, I guess. And it basically just does this. And type assigned would return false for anything that is not an integer type. Yeah. I think that's fine. Let's find the other type is's. We should also probably add, we already have type is integer, so it's a little funky, huh? So we have type is signed canon and type is signed. Return true if the given type is an integer type and has the possibility of being negative. Okay, it is signed. That's off the edge, I know. Otherwise, return false. In all other cases, just to make it clear that, like, even if you don't pass an integer type, it'll return false. I think this makes sense. And then we can do an implementation of these. Where's type equals canon implemented? It's right above that. Is L value? I'm gonna go type is signed, huh? It's gonna return type is signed canon on the type canonical of the given type, and so I mean, you can also just write and signed. IMO, it's pretty clear what signed means. That's true. Kind of overcomplicated that one. I'm good at that. I'm good at that. And this is just going to be that thing we had before. I don't have it anymore. It's gone. Okay, where did that thing we have before go? This thing. If... Here. I think that's fairly clear what that does. Where are we at? Serrade. Also, you don't need no discard on the definition. That's a good point in the C file. That is if the attribute we're using works the same way as C++'s no discard, which I believe it does. I believe so. Nix TV, first time chat. Hi, this looks like a cool project. Rock on, thank you. Is this also your own editor? No, this is not my editor. I don't have line numbers in my editor, or a mode line that looks like this, or an echo area. I just have a single foot line at the moment, and then contents and an optional headline that you can set. You could do line numbers if you really wanted to like calculate the percentage of the window that you need to use for, it's probably similar to what it would be in Emacs, it's just complicated. But yeah, no, this isn't my own editor. It's not that stable either. I'm working on getting everything actually purging it of errors so that it's actually usable and doesn't crash after 5 seconds. But yeah, this is Emacs, which my editor is based upon. Inspired by, not really based upon, because it doesn't use Emacs in any way. Or like, I didn't look at the code of Emacs. I just like Emacs a lot, so I made my own. Bit69 Dream, you made your own editor? Pog. Thank you. I appreciate that. I did make my own editor. I did. It even has syntax highlighting for C. It has a built-in Lisp programming language that is used to customize the experience and extend it. It's a good time all around. So we want to check if to is signed and if from is signed. Right? Yep. This, I think, makes sense. And then if two primitive size. See, we don't need two primitive size, we just need two size. From primitive size, we just need from size. This will shorten this a lot. Probably should have done this long ago. We should have done all of this long ago, arbitrary ints and stuff. If to size and from size, and either one of them. Okay, I see what this is doing now. So if we are casting to a signed type from an unsigned type, then it's not going to be perfectly convertible because we need to do the sign conversion. So we get a score of 1. Just checking. They are all singed. Gotta keep that knot in there. Nix TV says your own Lisp as well, I guess, in your editor. Yep. It's called Light Lisp. It's got a whole thing. Light Lisp. It's got a whole good introduction. I wrote a pretty good tutorial for it, I feel like. If you just read through this, I feel like it's not gonna be too confusing seeing all the terminology and stuff. Windows update. Pick a time to restart. Please don't restart me in the middle of a stream. But yeah, there's a whole like tutorial here you can read, and it starts with the basics like define and set and quote, and you get all the stuff with lambdas and macros and quasi-quoting, and it goes through all the special forms of the language, as well as some standard library stuff that I wrote, like structures in my language, as well as, you know, some examples. We have miscellaneous stuff. But yeah, try it out. Compile it yourself. No dependencies, just requires C to get the REPL. If you want like graphical, obviously there's dependencies for SDL2 or OpenGL, whichever one you want to use. There's multiple backends. Do whatever you wish with that information. Alrighty, and we can, honestly, these don't need to be like this. Right? We can kind of inline these, I feel like, without risk of dealing with too much. I don't feel like this is much less readable. It's kind of pretty clear. If the size of to is greater than the size of from, and to is signed, or, yeah. Or from is not signed, return 1. Beautiful stuff. Are you using Emacs? Yup. Is that a Soding fog? Where? In the Discord, probably. Not in the chat. Mad Flash, are you using Emacs? I think I already answered that. Yes. To is int and from is int. Can just do we use we use to is int down here, which is why we need to save these things. Cool. It's a little messy. That should be going better. Takes 3 seconds to print out 10 lines. Classic Windows. So I would like to look at the actual assembly and see how much horribleness is going on there. So it seems to think it's 8 bytes. No, that's an address. So then we move into racks. Yeah, it seems to think it's 8 bytes as far as it's using racks to load it. But that isn't correct. So maybe I've done something. Maybe I have done something. Looks like these are going well. Bit 69 stream. I saw it when you showed your light repo. Oh yeah, that's my I forgot. On Codeberg, that's my avatar. I forgot about that one. So cool. Let's run some tests. Make sure I didn't like break everything. So it says, by the way, completely unrelated, but for the docs, we can use the LaTeX package C++ program for highlighting source code that I wrote recently, legendary, because the alternatives that I know of are the listings package, which I remember being sort of janky, and C++ to LaTeX from like 1995. You can also use pigments as far as I know. I've got to run, but I'm super impressed after browsing the Intercept source. Thank you, NixTV. Be sure to stick around, hit that follow. Oh, you already followed 7 minutes ago. Thank you so much, Nix. Be sure to check out the YouTube, join the Discord so that you can get announcements every time I go live and never miss another stream. Thanks for hanging out. We love you, Nix. Have a fun time. Peace. What are we doing? Signed integer. Okay, signed integer. We didn't break everything, so that's a good first step. It doesn't look like we're doing the proper loading of this thing. This is 8 bytes long. That's not what we want. So why is type size of? How did I screw that up? So align bit width to 8. And then over 8. That should get us 4. So can we actually get the size of that we're using to calculate that in the CodeGen backend? Right, here's where we should be handling that. Nashior, what are we doing? Me every 5 minutes. I'm still putting off learning how to CodeGen assembly for real. Oh, actually, this might be a good time to hook you up with somebody in the Discord. Hook you up with them. Just tell you about them. Not like that. Not like that, chat. Don't read into things. Anyway, there's this Nashiora says, hi, that's me. You are local? Oh, that makes sense then. You're working on Laye? I'm gonna hook you up with yourself. I think you would like yourself a lot. Because it turns out you're working on the same thing as yourself. It's crazy. Oh my god, that's embarrassing. Sorry, local. Sorry, Nashiora. I didn't know. It feels so bad. So we should be using an R32 size. Nashiro says, no, you good. It's been a while since I was in stream chat. Bless. I appreciate you being lenient. Not lenient. You're not like the cops. What's the correct term? I don't know. Generous. Kind. Compassionate. There we go. You're understanding. Empathetic. I'm getting it now. I'm getting it now. Lenient? Oh, God. I gotta stop talking. It's gonna be a never-ending train. I'm gonna try and describe lenient, and it's just gonna go down a rabbit hole. And I'm gonna say something even worse. Lens reading out of a thesaurus just to communicate. I do that a lot. I say like 4 words that mean the same thing. Also, MadFlash19 and Elon Fask. Thank you so much for the follows. Not when text chat as often, but deaf when speaking. I feel like I don't know the difference sometimes. Where did I just go? Please don't do this to me. What am I looking at in the XID? So I'm looking for type size of. Where do we actually determine, right, the size for a given load? That's why I was looking at IR load. That's right. I'm starting to remember now. Okay. So we have a static reference, and we're just moving into size, which is reg size from bytes, type size of, instruction operand type. Okay. And the reg size from bytes is apparently not going well because, sorry for the flashies, because we're using racks here when it should be EAX. Let me just recompile, make sure it's still the same. Yeah, we're still using racks instead of EAX. We can get rid of these, by the way, for static refs. I don't think we actually need to omit anything, as far as I know. Do we ever actually use that register? Why is type size of going wrong? So when I get an arbitrary int, can I get the type size of it right after I make it? Right? Can I do like print size, type size of out? Show me what the size is, please. 4. Alrighty then. The size is 4. So, yeah, when it's a pointer. It's a pointer. Are we really not taking that into account here? We're not. We're not doing it here either. Hold on. This is bad. This is really bad. Shouldn't this be the pointer to of this type? Were we just getting away with this because our integers were 8 bytes and we never noticed? That's almost likely now. Oh no, we were. But hold on, that doesn't explain this. Why is there 8 bytes here? What? Hold on. When we're emitting a static now, why is there 8 bytes? Not memcopy, static. Emit static variables. Okay. For each static, emit a data section. Just optimizations, don't worry about above there. I think we are doing this. So I'm going to get rid of this to do. Sure. Sure. What is happening in this code? Sorry, it says Lamau, type safety go burr. Out the window, that is. First time chat from the Doriath. Are you making a compiler? I don't know. Are you? No, I'm not going to be the teacher. Yeah, I'm making a compiler. It's for a language I made up called Intercept, and it's a fun old time. And we're currently implementing arbitrary integer types. What is happening in this code? I don't know. Check the git blame and ask the person that wrote it. They should know. You got it, boss. The funny part is it's either me or you. Do blame echo. Okay, I have to switch the... Yeah. It's not in the right style. Hold on. There we go. Darn. That might be an issue. It may have been me. It may have been me. Can I turn this off? Okay. Manual. Oh yeah, we used to have the dot string directive. We don't do that anymore. Welp. Suraid says, quit blaming Lamau. I didn't even realize I said that. I did say, I'm like, quit blaming. Just stop blaming me. Jeez. This is not a big deal. I'm the one that opened it, but you know, stop blaming me. Fitty OX45 A69. Thank you so much for the follow. Nashior says, I don't remember writing anything more than a day old, sometimes not even then. I mean, I didn't remember whether or not I wrote this, so that has a lot to say. You didn't say quit blaming, I think. The maggot tooltip did. I see. Endianness selection. How fancy. What are we doing? So the size of var init immediate is a U64. This will always be 8. This isn't what we want. It's going to kind of be, okay. What is var type? Let's just get that. Can we get that? Not the size of, just the type. Just give me that raw type, big boy. Okay, so we get these, which means we should be able to get the correct size because it's not a pointer. So I think it's going to be as simple as this. I should never say it's going to be simple. I should never say it's going to be simple. When am I printing out size? I didn't get rid of that? Okay. So now, hey, PogChamp. 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 That's exactly what we want. So now we have 4 bytes defining our statics that are initialized. That's poggers. And if we didn't break everything, all of our tests should still work. It looks like all of our tests are still working. That's fantastic. Incredible. Just the 3 that were failing before. Ophidio X45. The 69 part was actually an accident. It's an ASCII code for E, and initially it was OX45 fiddy because E fiddy was taken. Put the numbers in the back for readability. You accidentally put 69 in your name. I don't know why that's funny to me, but it is. Your name is accidentally 69. But yeah, OX69 I think is capital E in ASCII. I think Deschar. Yes. Legendary. Thanks, Emacs. Did we just do arbitrary integers? I mean, we didn't, but I think we did. Which is kind of nice. Ain't it? Yeah, I think we did. That's pretty cool. Let's see if we can do something that's kind of bad. Or not bad, more complicated. Can I have like a U16 and then add them? I'm just curious what happens. Does everything blow up? I didn't want to run the test suite again. Efidi says yes, and the more hilarious part is that I forgot the password to the original Efidi account and was just too lazy. Oh no. We should probably add a check to SEMA to make sure that an integer type is not greater than an I64 because we don't currently support that because we can't even parse literals of that size unless you want to implement bigints internally in the compiler now. But if I remember correctly, bigints and you already have somewhat of a strained relationship. You could say that. Well, it did compile. Does it actually... Oh shit, it works. Efidi says yes, and the more hilarious part is that I forgot the password to the original Efidi account and was just... I already read that. I am a bot. I am an NPC repeating the same things over and over. What is wrong with me? I literally just read that. I looked at it and went, huh, there's some chat I haven't read. And I just read it again. And I had to get to almost the end before realizing there is something wrong with me. Ugh. Yeah, I think in the x86-64 backend, we should say we don't actually know how to deal with integers that are very large. Right? We should probably do that. There should also probably be like some sort of limit on how big a type can be, like 16 million bytes. Because if anybody needs a type bigger than that, they're wrong. What did you just say to do? Oh yeah, the integer types. So the problem is that we don't really know what integer types we have in the backend. So that's why you say do it in SEMA. I understand you now. Because when we type check type is kind of when we have to do that. So when we're type checking, it'd be really nice if we've like already decided all the code gen stuff. Efidi said, gosh, I thought I was stuck in a time loop for a second. It did feel like that. It did feel like that. So it says, you know, the unfortunate thing is that it did compile is not as useful as usual when you're writing a compiler. It's true, because it just means you're likely not catching an error. To do, it should probably be backend dependent. If tinteger.bitwidth is greater than 64, Error. Rejecting arbitrary integer of width greater than 64. This is a work in progress. Sorry. Cool. Okay, it still worked. 69 plus 69 is 138, as far as I know. Don't we have a diag sorry for exactly this purpose? I don't know. Do we really? We do. What do I pass to it? Oh, that's not a function, it's a thing. So I'd have to do issue diagnostic myself. File name, source, locate. Yeah, I'm not doing this. Oh, I see how it can happen. Okay, we have it already. It's called sorry, but sorry doesn't return, which is kind of sad. There we go, Lamau. It doesn't return false, which is a little worrying, right? Can you align these? Thank you, Emacs. Sorry, because this is an error. It just shouldn't be an error eventually. IRC sorry is like an ice. Is it really? Well, let's see what happens. Test. Arbitrary int too large. Ooh. I-96. Let's just do I-128, and it's an S. Sure. S-128. Return. Ooh. This is a test. Arbitrary. Is it not? Did I do the wrong thing? Oh, I did it in the wrong spot. That's going to be... Let's just rename this file into tests, and then we can open it in tests and close it there. Okay. Well, that's not good. It just worked, so a little bit of an issue there. It is not like an ice. That or we should just add a return false to it. I think we should just... Is it used anywhere else? It is used elsewhere. Not. No, it's just used by us. So I think it doesn't really matter if we change its definition. Nothing's relying on anything. This is a bit odd. I think that makes sense. What mad about now? Oh. Blink. Beautiful stuff. That doesn't look correct. I'm not going to worry about that. I guess maybe I wrote this assuming that sorry was like an ice. Probably. It's fine. It is fine. That's the tutorial stuff I'm working on. Okay, now we'll do arbitrary int signed. And I guess we'll just do foo as like an S32 equal to -1. Return foo. Expect -1. Also, this other thing isn't a test. This is an error. Nashiro says internal compiler exception. Ooh, very close. So long as it's somewhat fine, it's not a problem. Do you allow an S1 or an S0? We do allow an S1. I guess S1 might be a little complicated, because that's just a sign bit. But I mean, you could still do like -0 and 0 in an S1, right? That'd be weird. S1 might be something we want to disallow in the type checker. S1 is basically a bool. Yeah, that's what I was just thinking. Like, it's just going to be a thing. We may not want to have that be a possibility. So if t integer is signed, thank you, Fitty. That helps a lot. In fact, in LLVM IR, there is no bool. There's just signed bit, signed one. Interesting. And they use like the unary negate, I'm sure, to turn it into all one. That makes sense. That makes sense. That's not a bad idea, you know? We'll leave it. I'm not going to worry about it. We'll have it be allowed for now. If someone wants an S1, they can do it. LLVM IR has no concept of signed unsigned types. What? It only has signed unsigned operations. That's cursed. And Decent Labs says, hello, I went to the stream just to say hello. Well, welcome. Welcome to the stream. I'm glad you are here. Arbitrary int unsigned. This is kind of messy. How do we do an unsigned check? Do we... I know how to do it. Yeah? We'll see if that works. Arbitrary int signed GCC echo -1. Perfect. And unsigned. Nope. Nope. Yep. Well, we got 0. I think it worked. If we take a look at the code, actually. Yep, we can see it's all ones. Perfect. I mean, sorry, it says, I mean, that also works if it's signed, because if you add 1 to -1, you get 0. Because addition has no signedness, you'd have to do multiplication or division. So the last statement in files, just use the return value if it's an expression statement. Affidi, great observation. Yeah, the last expression in any block of expressions is the return value. And there's an implicit block around the top level of a file, which is basically the main of C, right? This is the block that's around the file. But yeah, so if you have like a block, anything at the end will be the return value. So this block returns 1. Hopefully that makes sense. Times -1 should equal 1. Right? I mean, it doesn't even really matter if we do this, because this is just going to be the largest number times the largest number in overflow. So how could we do this properly? To do an unsigned. Right? What's a good check for unsigned? And your test suite just reads the thing at the top and compares it to the returned value? That's awesome. Yeah, that's pretty much all it does. It gets more complicated because we can like specify the standard out as well. So this actually prints a string to the terminal, and this ensures that that string is that. So it says shift, division, multiplication. I'm just trying to think where they would differ. Addition, subtraction, doesn't care about sign and dis. Well, you keep saying the theory, but I haven't seen an actual concrete do this to test it, which is what I'm looking for. Because I can't really think about, like, if we took a signed 32 and made it, like, right? Made a sine 32. I don't know why I did that backwards. Equal to, like, -1. Bar times -1 is still 1. Right? It would just be 1 in this case. Whereas foo times -1, this should just equal, I mean, it equals 0, right? Depending on how the multiplication happens. It might equal 1 still. Because all 1s times all 1s equals like 1, 1, 1, 1, 1. Right? There'd be 32 1s followed by, it'd be like that. If you like 1, 1 times 1, 1, I think, is 1, 1, 1, 1, 1, something like that. So if we're doing something like this, the issue becomes that they'll both equal 1, right? Because if we just take the last 4 bits, aka bytes, right, we're just going to get 1, aka the same answer. Put one streamer into left ear and the second one in the right ear. I just realized I have I have 2 ears. You can use them both at once. Do -1 over 5. That's a good one, Sir Aid. That's a good one. I like that. Because a very large number over 5, it should be 0 as an S32, because, I mean, technically it should be -0, but it's 0, right? So as a U32, -1, as we saw in the code, apparently I closed it, as we saw in the code, it's all 1s, 255, 255, 255, 255. All 4 bytes are all 1s, right? Which means that by dividing it by 5, we actually get this huge number, which is, apparently Sir Aid says, 858,993,459. What do I do? What do I do here? I'm looking for, I could set all 1s by doing, so this is 32 1s, right? And to get 32 1s, I can set the 32nd bit, right? The 33rd, and then -1 from it, as far as I know. So we take 1 to the left 32, we -1 from it. -0 doesn't exist for ints, just floats, so you're safe now. Do I need to shift it to the right one? No, I think that's fine. And then basically from that, I need to divide it by 5. And what did that get us? Let's check messages. Interestingly enough, that got us hex 3333333. That's kind of fun. We don't have hex support, right? In like the return value output. Swade says, I guess we can just use that because we have hex literals after all. Oh, that's a good point. We can do this. Hash X, not hash X, this is an Emacs. OX 3333, 3333. Legendariness. And then this should be true, aka not 0. Equals equals, what a nerd. Okay. Hey, boggers, we got that 1. Okay, and then for the signed, what do we need to do? So this isn't really enough because this will happen even signed or unsigned. So again, we have to do division or something, which again, we can do the same thing, which should equal 0. I mean, technically -0, but it should equal 0. I am a firm proponent that -0 is actually kind of helpful. And it kind of makes sense. I know it's confusing, but it does actually kind of make sense. I hate to say that because it doesn't, I don't like things that don't make very much sense, but that's something that kind of makes sense. Even though it's very confusing. 89 tests now. We have 3 arbitrary int tests. Did any of them fail? Yes, 2 of them. Both signed and unsigned. So what happened there? Int C return non-zero exit code. Is this for the right one? No, that's return arrays. Where are we at? Overload block. Passing weird byte array. Arbitrary int signed. Failure C compiler return non-zero exit code. Well, that's an odd one. What does that mean? C compiler return non-zero exit code. Is it not compiling invisibly? Oh, that's an error. Legendary. So it says, but in linear algebra, a -0 does not really make sense. Not in, you're correct. Not all the time in linear algebra. This is actually an error. I figured it was just a warning like the other one. Unsupported instruction move. This is a little worrying. What is it talking about? What's not allowed? Can I not move from a 4-byte to an 8-byte? Is that not allowed? Is this what's happening? That must be what's happening. Because I need to move to an EAX. So in the code gen of division, of all places, we have the left-hand side size, and then we omit interesting. We're moving any size into the right-hand side at 64. So yeah, it looks like we're not signed 0 extending correctly because we can't divide 2 integers with different bit widths. So this has nothing to do with division. This problem is somewhere else. That's what I was thinking. I was like, wait, this should be fine. But I do think we're going to have to move, put left-hand side size here as well. And then we're going to have to do the thing where we say if left-hand side size is equal to R8 or left-hand side size is equal to R16. F omit red. I think reg to reg. XOR is what we need to do. And this is going to be a RAX. R64 scenario. Sema should insert an implicit cast. This shouldn't happen here. But isn't there code here that would do this either way? We just need, we're not doing anything. I'm just fixing the code that was here because we weren't zeroing RAX and we were trying to move into racks no matter what, even if we were moving from EAX or AX or AL or whatever. The backend shouldn't have to deal with code generating a U32 divided by an I64 or something. It's not. It's just using the same size on both sides of the move. U32 should be extended to I64. Yes. But the left-hand side, it stands to reason, should be moved into a register that's the size of the left-hand side. I don't think this is too crazy. It's exactly what we do when we load something. And it has nothing to do with the Sema not casting it, because once Sema casts it, then left-hand side size will still be consistent with whatever it's cast to. And it won't have to like match R64 and cause a random error. Right? Does that make sense? Am I crazy? I don't need to do tests. Why am I crazy? It's going better. Coco is a 64-bit operation. Yeah. So you're saying it would be better to assert that left-hand side size is equal to R64 and say x86-64 backend requires division of 64-bit numbers. Is this, yeah? We could do this. We could also use CDQ for 32-bit divide and so on. I think that's doable. We don't have CDQ or whatever it is. Convert double word to quad word, but we can add it. For now, I think doing this might be fine. So we could do this, or we could do, what's the other option? If size equals R64, do this. We kind of have to do this, don't we? That should be fine because, yeah. Also, there's yet another problem. Currently, we're always omitting an IDiv. Is that an issue? For unsigned division, we need div. That should be relatively easy, right? I don't think we have div as a thing yet either, by the way. So it would be great to like fix up division code gen because it sucks. What do we need? Coco plus IDiv for signed division and 0 out RDX plus div for unsigned division. So they're saying it's an even bigger difference. That's fun. Means we can do this. And then we can do like this. 0 out RDX for the top bits. That makes sense. What's the language called? Intercept. It's on GitHub. Links everywhere. Where you would expect them. Is this what we are expecting? This doesn't have a size, which is kind of worrying. You know what I mean? We don't have a size that's actually determining the size, which we should be. Where else does this happen? Why is it not happening? This thing, reg name. Why don't we use reg name? Probably just because it hasn't mattered yet. This is reg, and we're going to gain a size. How fun. Is it a reg size? Is it an enum? Okay, that's apparently what it is. Yep, okay. Now every time we call femit reg, we need a size. And by default, it's going to be R64, because that's what it was before by default. And we don't want to change all of these. We want to retain whatever they did before. This might be an interesting one to think about. A jump is kind of curious to have to give a size, but that's fine. Pushing registers, we obviously want 64-bit. Base pointer, we want 64-bit. Call 64-bit. Pop 64-bit. Pop 64-bit. Okay, and this is when it kind of gets curious. I think we should actually use the size of the result to do all of this stuff, because the size of the left-hand side is important here. Move dividend into racks. Yeah. For now, just racks. And then we're going to get the size, which is the reg size from the amount of bytes that the type size of the instruction result is. And then if the type, I guess this all has to do with the left-hand side size. Why did I need the result size then? Oh, because for idiv and div, we actually want the result size to be the thing. Is that true? No, this is the right-hand side size, because that's whatever's here. And we should probably assert that they're the same size, the left-hand side and the right-hand side. Gezi Parky says, hello, are you developing some sort of compiler? Yes, it's for this language, and we're just getting through some complications of arbitrary signed and unsigned integers in the x86-64 backend that we weren't handling in division. But anyway, we move the dividend into racks. From there, for signed types, we need to extend the 8-byte racks into the 16-byte RDX racks. For this, we use Pico. Convert quad word to octal word. Poggers. Probably just do this. Yep. That'll help. 4-byte sign types, we need to extend EAX into the 8-byte racks. For this, we use CDQ, convert double word to quad word. And then we want to omit that same type of thing. So yeah, we're just going to have it be the same as the dividend. We don't need the result size. The dividend can control the result size of the actual division as far as I'm concerned. And this really just has to do with the size of this, which is going to be, yeah, everything's fine. But yeah, to answer your Parkizzy Parky, I am developing some sort of compiler. Currently, we're working on getting some things worked out with the specific backend, because we've got some issues just with division, and we need to add CDQ and div now. Is there anything else we need to do here? If left-hand side equals R64, do that. We could look at the Felix Claudier, hopefully. And we can see that we have register 8, 16, 32. So it looks like we have opcodes for all of the divides, AX, DXAX, EDX, EAX. Interesting. So we still use the bot. We always use DX except for 8-byte divides. So for 32, then we're going to do, that's what CDQ does and stuff, doesn't it? Yeah, so this says DXAX, sign extend of AX, EDXEX, sign extend of EAX, RDXRX, sign extend of RAX. So basically this just lets you sign extend into very multiple registers. So if we're doing a 2-byte, then we're going to sign extend into that with CUDA. And then I think we're going to say else, like ICE, unhandled register size for division. And this is going to be word to double word. Sweden says, yeah, and because it's signed extension, not zero extension, it's for signed operations only, which makes a lot of sense. That does make a lot of sense. And then as far as unsigned division, I think this is the way to go. I don't think this is crazy. Sorry, I can't remember which way, but if you get that wrong when cogenning division, the program will crash horribly. Oh, good. So, yeah, I'm going to add an assert. This one's going to stick around, though. And if they don't equal, x86-64 backend requires divisor and dividend to be of same register class. I don't know how to say this. To be of same sized type. I don't know. Hopefully that makes any amount of sense. The left-hand side has to equal the right-hand side. Okay, now we can go up and look at Coco, I think. And we have ret, Coco. We're also going to have all the others here with Wuda, Kuwada, and Kudaka. So we have Kuwada, Kudaka, and Coco. And then what else? We had div. That's exactly what we need. We're also going to have to fix up multiplication, it seems like. and do this. Nope, not there apparently. Because we need to add a new instruction. Where can I do this? Here we go. idiv. Perfect. And then I'm also going to need some more, but let's start there and just see what doesn't happen now. It's weird that it's not showing the errors more readily. I coulda, undeclared. That's fine. Too few arguments to femit reg. So there's still some of those. Blup. Femit reg. Can I go through all of these? Apparently I stopped at some point. Yep, just stopped there. Modulo is also going to have to become more complicated. Fix me. Overhaul, like AirDiff. So when we shift left, it's probably just going to be R64. I don't think we want to deal with byte sizes. Just use the maximum size we can to deal with things. Okay, that should be us femit regged out. Afidi says, help, my Twitch stream started making weird noises like kuda and kuko. Modulo and division should probably just be instructed into a div mod function, for sure. Gezi Parky lil. Now we just have kudaka and kudako and kuda. No, not kudako, but kudaka and kuda. We just need to fix those. And then there's a static assertion. Femit must exhaustively handle all x86-64 instructions. So in femit, we do 27 because we now have, I guess it'll be the default, which is just ice, and we don't want to actually handle it here. That's a good point. We shouldn't even handle these really here. Let's look at how we use iCoco. So we use femit iCoco. Why do we do that? Why don't we do femit reg iCoco? Because there is no register, it just is a thing. Okay, I see. That's actually the only thing that should be an femit then. I'm getting it now. Chad's pronounced Kubuda as code. Cood even better. But what about Kubuda? Current working directory, exactly. So I didn't name this, guys. I did not name this. I would not name it this if I could choose. This is all Intel, baby. Where's Coco? Kudaka? And Kuwada. And then I'm going to have some more static asserts fail on me. In 301 and 654. So we have Kuwada, Kudaka, and Kuko. And then I'm sure we just have Kuwada, Kuka, and Kuko literally over here. Kuwada, Kudaka, and Kuko. Okay. Virgin. Kuwada. Chad. Good. Spelling hard turns out. It is. It is very hard. This should be fine as far as I know. I didn't go to that other static assert. That's going to be an issue. And that's just f emit, which we already added to. Okay. Surprising. Left-hand side does not equal R64. Okay. If it does not equal R64, we're going to have to do Dicka Woulda, right? Dicky Needles. And Nashiora says, I got to go play some ranked Apex. Very important. Have a good stream. All right. Hopefully you rank up. Good luck on that, Nashiora. I'll see you in the Discord. Good luck on you. Good luck on your assembly backend. I believe in you. Dean21, thank you so much for the follow. I appreciate it. I don't think there's anything we can really do. As far as, yeah. Because if it's 32 bits, then the move here should have handled the top 32 bits. If it's 16 or 8 bits, then this will have handled it. So this is just needed here. And then this will sign extend into RDX or whatever if need be. And this is if the result type is signed. Is this how we want to do it? I think that makes sense because like if we do a negative divided by a positive, the result's going to be negative and we want to do a sign division, which means that it's going to have to end up with a negative type or a type that is signed in the result. Also, don't divide by 0. Right, that's going to be negative. So I think this will just be up to, yeah. This is fine. Everything is fine. Sorry, it says, by the way, also unrelated, but I just remembered, you said you were thinking about doing a stream in VC on the Discord some time ago, right? Yep, that's absolutely a plan. That is a plan eventually. Welcome, thank you so much, Bitch69 Dream. It's so good to have you. Welcome to the Discord. You will now get announcements every time I go live, and you'll never miss another stream. Pauga champ. But yeah, sorry, that's definitely in the plans. Yeah, into the 8-byte EDX, EAX. And then for 4-byte, 2-byte sign types, we need to extend AX into the 4-byte DXAX. For this, we use Kawada, convert word to double word. And this is going to be convert double word to quad word, which I already did. Okay, perfect. Bit69 Stream said Pog. Hey, Pog champ. Pog champ. Okay. So do we need to zero out RDX kind of no matter what? I think we do. For unsigned types, we need to make sure RDX is 0. RDX is 0. That way when we actually top bits. If it was set, it would mean it would cause a signed division, and we don't want that. Beautiful stuff. Bit69 Stream says, I actually found you because of your YouTube vids long ago and followed on Twitch. And only today I caught you live. That's awesome. Well, I'm glad you could catch me live. It's interesting to hear how all the different people discover me. Some people just like stumble upon it on Twitch, and some people are like, oh yeah, I saw it. I've been watching on YouTube and I just saw you had a link to Twitch and I clicked it and you were live. But it sounds like you had the determination to keep checking. I appreciate it. Talray, thank you so much for the follow. I don't know if I already said that. Where are we at? I think we're good. Here, right? We really should have some more tests for division as I do this. And it says it only allows division of 64-bit numbers. That should no longer be the case, as far as I'm concerned. Left-hand side size does not equal right-hand side size. That's a big deal. Backend requires divisor and dividend to be of same sized type. So we're getting a division with 6 and 8. 6 is a U32, 8 is an integer literal. Now, integer literal is kind of implicitly convertible to any type of integer, and that should be happening at some point, but it's not, right? So if we try and think about when this would happen, bit 69 stream with the Morty face. With the function nodes, if the sort of, so what am I actually looking for here? What am I doing in the type checker? In the type checking phase, I would like to say, okay, we disallowed divide by 0 right here, right? We require both sides to be integers. So is it here that we should insert the cast from the right-hand side to the left-hand side if they're different, or a division, or modulus? I think it might be. So it says, yeah, I think so. Legendary. Legendary. Okay, so we disallowed divide by 0. Division modulus. We disallow divide by 0. And then we also want to disallow, not disallow, but if not type equals, right-hand side type and left-hand side type, right? So if they're not equal, could you insert a cast? It seems a little messy. Is there somewhere else where I do anything like this, or am I just all on my own? Probably all on my own. So if they're not equal, then I would like to make a cast expression. Oh, we do this somewhere, but it might be in CodeGen. I remembered writing AST make cast at some point. Yeah, here it is. Here's almost exactly what we need to do, right? If they're not convertible, obviously it's an error, but they're both integers, so they are convertible to each other. We don't need to check that. Here it is. So in this case, we're saying if not type equals a parameter and an argument. Otherwise, we want to insert cast from right-hand side type to a left-hand side type as they are convertible, but not equal. There's probably somewhere this could go as well. I just don't know where. So when we make a cast, we're casting from the right-hand side into the left-hand side type. And then we want to say that our expression, which is a binary expression, has its right-hand side replaced with this cast. We should probably type check this cast, right? That's also a thing. something like this. And that should, quote unquote, just work. We may be type checking things. See, we're not going to type check the right-hand side twice. Yeah, it's top down. We're good. We're good. Never mind. I forgot. Anyway, that worked, so that's cool. You can see that the div is now a U32, and that's all been filled in where it needs to, so that's pog. And the real goal... Hey, we got a 1. GCC didn't give us an error either. So that's pog. How do I keep doing that? Oh, what have I done? Okay, well that's confusing. Anyway, that seems to have worked. So let's try running our tests again. I think it didn't work. No such instruction kudakaka. So I screwed up the instruction type for signed division, but it seems to be working with it. It's not kudaka? I might need to go compiler explorer on this one. Oh, do we got a new... Oh, Jorgegon. I don't know how is that Jorgegon? I want to shape with Jorge's sides, and that's a Jorgegon. Welcome to the Discord, Jorgegon. It's so good to have you. Mintulep, good luck, have fun. Thank you so much for the follow. What's New Shell like, by the way? It's nice. I like it. When you do ls, there's like, it's broken into tables, right? And then you could say ls, and you can like, it's kind of like a query, right? I think you can select name and stuff like that. So you can really easily find like, okay, select name and then find, ooh. See what I mean? You can really easily pipe things together, and I think it really takes the Unix workflow and like modernizes it. I really like New Shell. If there was another shell that had better editing capabilities, like I don't like the history, New Shell's history. It's just not my cup of tea. I don't think, it's just confusing. And then multi-line editing is just a mess in this terminal. But that might just be this terminal. But New Shell is kind of just, multi-line editing is hard. And it's never clear. I don't think it's bad though. I prefer New Shell over any other shell, pretty clearly. Unless it could get faster. Use Emacs as shell. I mean, I do. I use eShell a lot. I use eShell quite a bit. It's just not as, I mean, so one thing I do like is the history is way better in Emacs, where I can like find something I've done before, and I can copy and get something from the output and then use it in another thing, right? Because this is all editable text, which is really nice. I prefer POSIX compliant shells, says Sarade. Yeah, I don't. That's not a I like workflows. And POSIX isn't a workflow. It's just like, here's a technical spec. It doesn't really match any real use case or goal. Bit69 says, yeah, I know, I'm also an Emacs user. Oh, lol. I didn't know. It's good to see you're one of the club. That's right, just kudaka. What is that supposed to be? Oh, Jesus, that's bright. I just blinded myself, I'm sorry. What are we doing? This is so bright. This doesn't say anything about what they're called. Mnemonics. Can you just divide two numbers for me, please? And do not do that thing. Okay, yeah, that's not helpful. So how do we get this not to do this? Well, that's closer. God, this is what they do without optimization. What is this nonsense? This is a multiplication. Divide by argc or something. Okay. That was hard. The better syntax, please. Ah, yes, clearly it's long. Convert long to double. Long? Is that really what they're doing instead of word? Why is L to D? What is this? It doesn't even give me anything when I hover over it. Can you please? What is it? We'll get there. Not any of that stuff. Wow, this is a heavily undocumented instruction. That's why Intel syntax is the superior syntax. Why? Because you know it? What do I gotta look for? Here, hold on. Let me send you guys to Emacs while I look for something. Okay. CDQ. CLTQ is there? Okay. I think I found it. I had to do some searching and it's very bright. Okay. The Intel syntax conversion instructions, the Intel syntax extension instructions, right? Here's what they're actually called. So sign extend byte in AL to word in AX. Sign extend word in AX to long in EAX. So where we are saying double word, they are saying long. However, yeah, so it's CWTL, which makes sense, I think. And it's weird they have two sign extensions. I'm not going to worry about that. We're just going to use the regular ones. So we don't want cawiddle. We want cawiddle. We have CBTW, CWTL, CWD. So the third one, CWTD, is what we need. Why am I not there? What did I just say? CWTD is what we need? That's what is there. Am I insane? Oh, that's, yeah. So we need CDTQ, sign extend double word in EAX to quad in EDX, EAX. That's exactly what we need. And it's just CDQ, the fourth one. 1, 2, 3, 4. So we need CLTD. Cool. You want CDQ, CWD, and not CDQE, CWD. Yeah, we want it the top bits in D, the register, D. That should work better now. Oh, man. Hey, it worked. It's passing. We did it. Couldn't they just have made a table? Like, I know this site is probably from like 2000, judging by the CSS, or rather lack thereof, but still, I'm pretty sure HTML probably had tables even back then. The problem is this is like a, it's written in tech or something and converted. You know what I mean? I don't think they wanted to, like, infotech or tech info. You know what I mean? I think it's just a simple version of that. Or maybe it's just like a, written as a man page or something, because it doesn't seem like they have tables anywhere in the GNU documentation. Stray slash in the program. Oh yeah, that would do it. Very not useful. Good to remember. Cool. Hopefully we never need to look at those again. We did it. We did it. I did it. We have arbitrary integer types. Is that correct? I think that's correct. Let's think about what that took. Unmerged into main, we have tutorial writing. That's fine. That's right. We did now technically implement all these things. Boink. Man, that's satisfying, huh? Check that off the to-do. We'll just add that and say to done. We have arbitrary integers in the grammar. That's right. We could add like is signed by itself. That may be something to do. So it says also, wait, it shouldn't be coital and not coitida? Or did I read that incorrectly? Hold on, you're making me doubt myself. What are you talking about? Cultida, coital. So we need coitida, culitida, and cookito. Coitida, culitida, and cookito. Yeah, that's right. We got it right. I like the double check. I like the double check. Shroid says coitida and culita-q is what we need and cookita-o. Is it really? I don't think it is. Because culita-q is this. We don't need this. Oh god, they have coital and coitida. Yeah, because they're different. A double word is two words in two different registers, or a quad, right? That's what they're saying. Whereas a long is in like a single register. I mean, they don't say that, but that's kind of what's happening here. The order, it's the wrong way around they list. What do you mean? I don't know what you're talking about. Convert word to long. Convert word to double. Convert long to... sign extend word, D word and EAX. Yep, the long to... I mean, I don't know. Put CDQ first and then CDQE. Why? That would simplify a lot of things. It's because they want to keep x86-64 at the bottom, I'm sure. I hope it's working either way. The order they're listing these in is weird, is what I'm saying. Yep, it's very weird. I would agree. This doesn't make... This one is even worse. It's bad. What am I doing? I'm going git. And I was going to do that thing where I did like Ah, yes, let's do type is signed by itself. How poggers. Type is signed. Well, type is signed, here's the thing, it kind of relies on the integer type, doesn't it? Existing. So we can't add that until we add the integer type. So maybe we should just try and add the integer type, but no parsing or anything of it. Like, this is all bike shedding, none of this matters. So type integer struct, add it to the thing. See, but this is going to require all the static asserts to be updated. So, yeah. So we need the static assert of types. Is that what's going on? Oh, Lord, that's kind of messy. Line 2, that's something I did as well. I might just have to do all this in one. Not doing well. So it says, so they sometimes call 32-bit numbers longs and sometimes double words, depending on whether it's split across two registers or not. Yeah, that's kind of insane. I would agree. Adding the E at the end does make it easier instead of trying to make like two different names for things. I'm going to add a line 2. I don't think this will require very much anything. We're going to do the styling as well when we type check types, just so that can be fixed in the same one. Fix this align to. Why are we adding return true here? Did we not return true here and now we are? Why is return true being added? I don't know if I like that. Do we have return true twice in the type checker? We don't. What have I done? I did something. Look a few lines below. It's just Git being stupid, I think. I think it's not being stupid anymore. This is different. I'm not looking at the same thing, right? Am I crazy? This changed, right? I feel like I was just looking at something else. Whatever, it's fixed. This makes sense. This does make sense. Right? So now what do we have? We have align to, and then we have its use twice. Okay, I didn't, this should be fine. Everything's fine. If I didn't have maggot, I would be done for. I almost wrote kernel. I've been doing too much Lenser OS. Utils. Align to make aligning upwards easier. Multiple. Sure. This is why I dislike these kinds of diff views. I prefer having 2-3 windows side by side. Okay, so we did align to. We can do this fancy sorry fix up. I think that's fine to put here. Make sorry actually return false. Okay. We don't want to do the x86-64 backend first, I don't think. That wouldn't necessarily make sense. Yep, that's the tutorial. Still need to work on that. So maybe now's the time for type integer. That's probably what now is. 2 for diffs, 3 for merging, that is. I've got a more like, let's see what happens. Let's press buttons and figure it out. So we now have this new integer type. Happens here. This static assert matters. We need to be able to print it. Getting the size of integer types is quite important, as it turns out. And then it's going to give me the hunk for the last one. And now we just have type is signed. And we can fix up type is integer. I don't think we have any more static asserts on the types, or at least the type kinds. So we should be good there. And then this is going to be for type checking an integer type. And then this is part of the division fix-up. That's something else. This is also part of the integer type, but it uses type is signed. So maybe I'll introduce that next. Did I have to handle anything crazy in here? I know I had to change code gen. It always means a million changes. We changed division. We fixed the pointer to thing. That was a big deal. Type size of our type. That's a static assignment thing. So none of this really comes into play, I don't think. Just for the type. We aren't parsing arbitrary ints yet. So yep, that's all the changes. This is going to be, I don't even know. Arbitrary integer type. Just a new type, that's all. And now we can do, I think, type is signed, and that would make sense. Then we can use it here. Don't need it there. This is all parsing of arbitrary integers. Not using any types here, that's all the code gen. Okay, and then this is going to be semma fix integer type size and signed comparison. We now use the type is. We now use the type functions to gather the info rather than assuming that if it's an integer, then it's not then it's a primitive. PogChamp. Now what? Now what? This one's a little tricky. We're gonna kind of have to do this all at once, I think. One thing we could do first is this fix up at the bottom, where we use the size of the type to actually emit the compile time constant. That should help a lot. And then we can do that pointer to bug fix. And that should be fine. x86 64. Use integer type size instead of assuming 8-byte integers. That should be flipped. Respect type size when emitting compile time static constants. Compile time known statics. Sure, whatever. No on, known. Use integer type size instead of assuming 8-byte integers, basically. Cool. This is a funny bug fix. Static ref. Static ref's type is a pointer to its underlying data. In order to get the register size needed to store the underlying data, we need to drop one level of pointer in direction before getting the size. This only worked before because integer is 8 bytes, and so is a pointer. And this is basically going to be fixed type issue regarding loading of statics. My syntax highlighting thing can now highlight escape sequences and strings as well as comments properly. That took a while. Yeah, that sounds horrible. Why have you done that to yourself? I'm gonna leave that for like the div fix up, right? Because the arbitrary int doesn't actually compile into anything. Yeah. Yeah, I think that's all pretty standard. Parser is the easiest part. That's all the division fix up. Oh god. That's all that. I gotta. Okay. Sraid says, because I like syntax highlighting. Okay. It's okay, Sraid. It's okay. Honestly, syntax highlighting is really nice. It's just a luxury that is like, it's nice. It's not necessary for me. Like, sometimes I have fun like going into text mode instead of having like C mode and have all this fancy stuff. Like, just give me text. That's all I want. Sometimes I do that, but most of the time I agree. Syntax highlighting is baller. I can post a screenshot on the Discord if you're interested. I am interested. Specifically the escape sequences. I'm mostly curious what color you chose compared to the string. Is it a brighter color that the string color is? Because that would be my guess. Like if strings are blue, then the escape sequences are cyan or something like that. Parse arbitrary integer types. Cool. So it says not quite, but that's an idea. You'll see. Legendary. Okay, can we look here and think about what modulus is? Honestly, they're going to be the same instructions, aren't they? It's just where we get the answer from. Hold on. Let's just, whoa. Didn't we used to have a div mod. I can search for div mod. IRDiv. What do we got? I mean, this is pretty clear. Yeah, let's just copy all of this and we'll get back to you. Dunk. So when we have instruction, what is that actually? Div or mod? It's the div or the mod, right? We can just call it instruction. I think that's fine. So now that means we also don't need the left-hand side or right-hand side, which is pretty pog. I've put it in code review. Disclaimer, the document is in light mode. Oh, my eyes. No, I'm kidding. This LaTeX code, oh my god, that's so nice. If you haven't used LaTeX before, this syntax is like amazing compared to any other code highlighting. Very poggers. Oh, they're purple. Very nice. Purple instead of green. So they're keywords, basically. I see. I think I know how you've done this. That's cool, though. That's really cool. This looks so good. In LaTeX, it is so hard to get code that looks this good. This is really cool. I'm definitely interested. Nope, they're not keywords. Oh, that's nice. So you can make them any color pretty easy then. I'm gonna need a context. And then this is the thing that's going to be unique. For modulo div or mod. Div mod must be passed a div or mod instruction. Coolio? Hopefully Coolio. And now all of this should be able to go away. All of this should be able to go away. Can we go ahead and test those? Let's try out like rule 110 or something. Well, all the tests still pass. I want to do a specific test just to make sure. Like, what is 8 modulo 3? I guess I should do like foo is a u32 equal to 8, and then bar is a u32 equal to 3. Foo over bar. Right? Which should be like 2. This should be 2. Invalid type kind 7. AST.C 1251. What's going on there? Type equals canon. Ah, nice. Never implemented equality. That's good. That's a good sign. Oh yeah, we forgot about that, Lamau. Well, it's kind of our fault. We need this thing here. But we're not too smart, I guess. And didn't put it here. It was definitely me. Exhaustive handling of types in type comparison. Can we just mem compare? So we want A integer is signed to equal B integer is signed. And A integer bit width to be equal to B integer bit width. And that's it. Lamau. Well, that's looking better. We now 0 extend and copy. That's a poggers. And if we try and run the thing, we get 2. That's exactly what our answer should be. Poggers. Okay. Okay. And then we should also do modulo, I guess, just to try it. 8 modulo 3 is going to be 2 as well. So that's kind of confusing. Let's go 7. That way we get 1. Legendary. And if we go over bar, do it all again. Didn't really need to rebuild the compiler. Now we get 2. Okay. They are apparently working. What have I done? Parse arbitrary sized integer type. So we're already parsing them, so we're already kind of screwed, but it's fine. It's fine. We're going to say AST. Forgot to compare them. Oops. Add type equals entry for type integer. Perfect. And now we can go ahead and probably go do this part. That's not all of it. I forgot the type checker bit, which also helps. Okay, now x86-64, overhaul division modulus codegen. It now handles differently sized operands as well as not differently sized operands. I don't know how to say this. I'm just going to leave it with overhaul. People can figure it out. Not going to be too difficult. And then we can add our new tests. We actually, before we do this, may want to do this thing. And say to do, done. arbitrary sized integer types. Sorry, code gen overhaul. Oh god, no, the flashbacks. Did I just do all those tests in that? I did, didn't I? Yeah, I did. Well, yep, I'm pretty sure we're gonna have to modify a commit. We could really just rebase once and not really have to worry about it. What's happening right now? Apply unstage. So I wonder, this isn't working well. Why are we stopping? We're in the middle of a rebase. Edit. Okay, this isn't gonna help. Abort this rebase for sure. Because I just need to basically rebase once. It went... That went well. Can we not rebase anymore? Legendary. So I just need to extract the last commit, basically. Isn't that called something when you rebase? I'm gonna try and remember this. Is it drop, pick, reword, edit, fix up, exec? We're gonna try and edit. We're gonna see what happens. I've never edited, so yeah, that brings me here. How am I supposed to edit this here? Can I like just unstage, reverse? Sure. Very nice. That's not what I wanted. So I want to reverse these three. And then hopefully, because I have these changes staged, that I deleted them, then when I go through with the rebase, we should actually have deleted those. And then that's what this is telling me. I want to do that. Beautiful. And now, Jesus, see how difficult Git can be? Now we want to add the tests. We want to say arbitrary sum, very few, arbitrary sized integer tests. Cool. Boink, boink. We can push that everywhere. And the code is now live for you to gloriously, this is going to be bright, gloriously check on GitHub. You can now clone it yourself and have arbitrary sized integers. How pog is that? One thing I do want to check out is, can we actually fix up these integer types? Return value, 4-byte unsigned int. Signed int. 4-byte unsigned int parameter. Lol. Integer type fix up. So let's look up SDL create window, I guess. It's int uint32. So that's a bunch of S32s followed by a U32. Yeah, we can do this now, and we can say type. We could do event type, I guess. We'll see if we can get away with type. Type is going to be equal to a U32, and SDL event type. Can we now just return out.type? We're gonna see what happens. Expected identifier got type. So that's just the keyword thing. So we need to actually do event type. Sure. SDL init, argument of type integer is not convertible to parameter type U32. Where is that? In SDL init? So I probably have to do something like that. In which case, it's probably easier to just do this. Sure. Also, puts returns an int. Good point. Ah, very good. SDL create window. Argument of type integer is not compatible. And it's telling us what? The width and height I made probably aren't correct. Window pause. It's probably going to be a U32 as well. We probably want to make it easier to convert between integer and S32, don't we? Why isn't this allowed? They're not convertible because this is larger than this one, I'm pretty sure. But they're both signed to signed. I don't know. We'll think about it. It just needs an explicit cast, I guess, is the issue, because we're losing data. Well, we're getting better. So window pause undefined can be an S32. Nope, that's not a safe conversion because it's not a literal. Yeah, you need an explicit cast there. Exactly. That's going better. It at least works now. Not this one. That one. Suspiciously, it's not doing anything. Little worrying. It compiles. As is hanging. No, as isn't hanging. As isn't hanging. It compiles. Everything's fine. It's just that it just loops forever without ever doing anything. Why has such things happened? I broke things. Call SDL init after moving SDL init video into ECX. Can I like get some basics maybe? Window created. SDL initialized. Oh, okay, that worked. PogChamp. First time chat from Slacer. Is this Emacs? Yes, it is. I was going to say, if a program causes as to enter an infinite loop, then something went horribly wrong somewhere. Yes. Well, we did it. I don't know what did it, but we did it. We fixed it. So if I don't puts, does it not work? Is it something horrible like that? Like register allocation or... Yeah. Something bad like that. It's gonna be rough then. Why are we using R9 here? That doesn't really make sense. We're doing... I see. I see what's happening here. Really, all we have to do is move racks into R9D and everything would work fine, but this is fine. Yeah, I don't know. EAX to R9D, but yes. Yeah. Well, that sucks. Because having these print statements should do nothing, and it's doing something very, very heavy. I might have to step through this in GDB after the stream or something. I don't know why it's not working necessarily. Even given what we changed, I'm not sure what will have changed. You know what I mean? Because we changed the signatures of these things. 1, 2, 3, 4, 5, 6. That makes sense. We allocate 2 of them on the stack. Is this in reverse order? It is, because the S32 is here, then the U32, okay. Slacer says, I have a lot to learn. I don't know what I'm watching. That's fair. You were on part 52 of a series, so it would make sense. So we're truncating these integers. That should be fine. Not that one. So window pause undefined as S32. So we're going to compile this SDL example, try to actually compile the assembly it generated, and then run the program. It's not actually working for some reason. Which doesn't make a ton of sense to me, because it should be working. There's no reason it shouldn't be working. We use ECX here to store SDL init video. We move 0 into RDX, we compare ECX, which is our new return statement value, right? So SDL init returned into RCX. We're comparing EDX and ECX. And if it is 0, we move. Yeah, we're basically setting AX based on whether or not it is not equal to 0. Okay, and then we test racks, jump, 0, jump. Sure, sure. So if it's 0, we do the thing. Otherwise, we jump to L1. In which case, we move the string literal and RCX, the address of it, with Leah. Call puts. So that quite literally just calls puts. Otherwise, we jump if not, or jump if is 0, which means it was not 0. To L2, where we print a string again. No, just this is for SDL tutorial. And then undefined, 640, 480, 0. Slacer says, I basically just came hard after making Emacs my Java IDE. What? With LSP, and I came even harder after learning that dabrief existed, and I looked for a streamer more experienced than myself with programming and uses Emacs. Well, you found the right person. I don't know if I'm more experienced than you, but I do know code on some level. Sorry, it says that's an interesting way of phrasing it. Yeah, it is. I was hoping that it got better, but I read it and it didn't. I was like, I figured just reading it would give people more of an idea than me saying anything about it. Laser with the heart. I don't know if I should be creeped out or worried or what. So we push the base pointer and then sub 8 off of that, and then we push the base pointer and sub 4 off of that to get our -8 and -4 off the base pointer. And then we continue to do things like that. So 32 plus 8. Why are we subbing 48? I don't know. Ah, yes, because of the things we pushed. So 32, 40, 48. Move RCX into window, move window into racks, move 0 into ECX. If it's 0, do the thing again. Call puts and exit. Allocate 248 SDL event. Well, that's an interesting one, isn't it? 248 for this? Isn't that double the size it should be? Am I crazy? What? What did I do? This has to be... Sorry, it says fascinating. Slacer, it's for x86-64. Is it in this first one? So we do T structure byte size to alignment. T structure byte size to T structure alignment. This is value plus alignment minus value minus alignment. Plus value minus alignment modulo alignment. This is just odd. So I think I know what's happening now. The alignment of data is 124. Yeah, this is wrong, Sir Aid. Sir Aid, our alignment code is wrong. This sucks. Because what did you do? I didn't do anything. The alignment code is wrong. We have a 124 byte array as a member. The alignment of an array should be the alignment of its element type. Yeah, I think that might be what's going wrong. So what's the align of an array? Type array. It's not it's not the alignment of its element type. It's literally aligning the whole array. A little bit ridiculous there. Okay. Just first of all, that should help us. Okay, it's not the solution, but it did make it exit eventually. At least it exits eventually. Okay. And that should now fix the declaration to be 128 bytes. Legendary. Okay. Legendary. SDL events are now the proper size. So that's step one. What's another step? What looks wrong here? What could we possibly be doing wrong? Let's go look at the create window type of thing. So we have an integer literal truncated to meet a U32, S32, or we just have them. Right. Does it have to do with the comparison? I don't think so. It's at least not going forever now. I think at this point, stepping through it in GDB wouldn't be too insane. I'll leave that for off stream. I don't think that's going to be interesting. But why didn't it work? It's got to be some register allocation thing, right? That's what we determined, because we can add the other things and it starts working. So ideally, we're looking for things late in the program that use something early in the program without loading it first. Call SDL quit. That's L14, okay. Another curiosity that I'm just curious about. What if we optimize it? Okay, optimizing it does not help. Had to check. So it's likely a bug in something else that we're just running into now. And honestly, I don't know exactly what it is. I'll figure it out eventually, though. I'm sure I will. Oh well. I don't know why this is broken, but it is. to be like this. I don't think it would be getting the offset, because that shouldn't be too difficult necessarily. Here we allocate the 128 and a pointer to an integer on top. Why do we need a pointer to an integer? I don't know. What is it used for? R8. We store a 0 into it. And we load an integer from it. Oh, that's quit. I'm smart. Moldy the Man says hello. How's it going, Moldy the Man? So yeah, that's quit is what's happening there. Quit is becoming an integer, so we get a pointer to integer on the stack, but it's actually just an integer because whenever we access quit, it's actually an L value, so we may need it. It's okay, I'm getting it now. If event type equals blah, we're calling SDL poll event, which returns an integer. Well, we're getting there. I'm just chilling. What about you? We can use SDL now? Pog. Yeah, we could before. I've broken things. But if you just go to like the repo, yeah, you can use SDL now. It's been there a little bit. It's just not going too well. Well, let's see what happens. Right? Let's see what happens. It's not going to be great. Why did 3 new threads start? I'm not going to question that. It's SDL nonsense. Where are we at? Right, so we can disassemble. We can see we're going to push and then do some. So I want to get all the way to this call and see if we actually in it. So I'm going to actually step in a bunch of times. Right? So now it looks like 1, 2, 3, 4, 5 maximum. Okay, here we are. We're at the call. We look at our registers. RCX, we have 32. Right? RAX, we have some crazy number. So now we're going to do next. And we got a seg fault. Which is quite interesting. So we got a seg fault in SDL init. Is that what happened? What's going on there? Int uint32. So it returns an int, takes in a u32. Why are you mad? Return 0 on success. What do we pass to SDL init? We pass SDL init video. SDL init video is a u32. Bit 69 says simple direct media layer 2 just being simple. Lamau. Anosirius says hello. What's going on, Anosirius? So good to see you. We're just about finishing up the stream. Just so everybody knows. I'm just not sure why this isn't working. So we somehow got a seg fault in SDL init. How does that even work? Because we don't do anything. We're just passing it SDL init video, which worked when it was an integer. So what if we just change that to an integer and change this to an integer? Does it get crazy? Does it work? It doesn't work, for sure. So that wasn't the change that broke it. Is it returning an S32 that breaks things? Does it need to return an integer? Nothing like that, it doesn't seem like. Anosir says, I'm gonna try to write some C and probs fail miserably. That'll be fun. That's what I'm doing right now. Yeah, I don't know how I broke this. What if I did like that? It used to work, I swear. Error mismatched operand size mismatch for move ZX. What? Yeah, that'll cause some problems. Why will that cause some problems? Shouldn't this be fine? 32-bit to 64-bit? Am I crazy? If you push the commits to upstream, you convert to last commit. It works and apply commits to one by one to find where error is. I know it sounds dumb, but that's what I would do, to be honest. We got some crazy... I don't even know what character that is. Something. It doesn't even... Here's the thing. I'm pretty sure I just changed it. I'm pretty sure everything still works if I don't change this stuff. Let's try it. Let's try it. It's gonna put both of these things here. And then I can stash... I think that would be the index. And this is gonna just say whip whip. Okay. It's now reverted back. Let's see what the hell happens. Beautiful stuff. It works. It works. Is C out a C++ thing? Sadly, yes. Okay, well, we have a little window. Let's see what I did to break it. So let's not change SDL event at all. Let's just go through and change this and say, this is now U32, these are two S32s, and these are two S32s. This is an S32. Init video is a U32. Event quit is a U32. Puts returns assign 32. This returns assign 32 and takes a U32. Can we see what happens now? Still compiled. Now it doesn't work. Ugh. Why? Why? So I can't even just change some basic types. That's no good. Debugging time. We already used a debugger. It didn't help. It tells us we crashed an SDL init, which makes no sense. Put your code in a C file. That should do it. Lol. If you're in Visual Studio, there's no way to make that happen. Just so you know. It just will, there is no difference between C and C++ in Visual Studio as far as I can tell. So we're back to it working, just to be clear. Back to it working. Okay, now let's change one thing. We're going to change SDL init to return an S32. That is all we changed, was the return type of SDL init. Okay, and that's fine. Let's change the parameter type of SDL init. How about that? Instead of being an integer, it's going to be U32. Yeah? Still compile? It now says we don't have a U32 with what you're passing to it. So now we just make this a U32, because that's what we're passing to init, SDL init video, which is a U32. Okay, we've changed its parameter. It still works. So SDL init changing is fine. It's not SDL init changing that breaks things. So what is it that breaks things? I'm guessing it's this change then. Right. It's got to be the calling convention. If you want to try out the Visual Studio thing, just try and use decal type or something and try and see if Intercept still compiles. If it's treating it as C, it won't. What's the size of an integer? Like this type of integer is 8 bytes. Afidi says, man, I am happy that I am as far away as possible from Visual Studio. Me as well. I cannot stand it. Okie doke. So as far as things going well, it seems like maybe it's a calling convention thing that we're getting wrong. It's got to be a calling convention thing that has to do with SDL create window. We allocate the U32 at -4, but the S32, this doesn't seem like it's in reverse order. That's one thing that's interesting. We know that we have shadow stack space. We know that we have subbed 8 and then subbed 4. Well, that puts them in reverse order. and you're wanting to use a 4-byte integer instead, is S64 U64 a thing? It is. That's not the issue here. SDL create window returns. I don't need to go here anymore, by the way. SDL create window returns an SDL window pointer, but it takes in integers from C, which are S32s. It's not about a type error. It's something else. So we add 48 because 32, 40, 48, which gets us back to wherever we were here, which means that we can then pop our 11, 10, 9, 8, DX, CX, add 8, move racks. RCX pop racks. Okay, so that seems to be working. Move RCX window rip, move window rip RAX. So it seems like somehow they're accessing the wrong thing. So is there like a minimum size in MSVC or something? Or where things are stored? This might be an x64 calling convention specificity. The fifth and higher arguments are passed on the stack as previously described. Okay. Has a double word alignment, which is 4. Calling convention defaults. Okay, blah, blah, blah. I don't see it here. Where's the stack? Yes, okay. That says in registers. FVDOX45 says all of those click menus where you need to search for a completely hidden tiny input field to add something to the include path. Just give me a makefile and I'm happy. Exactly. Exactly. When there are varargs. Type binding ensures that the following table summarizes how they are passed. Well, Coolio, F then E pushed on the stack. So are they pushed? I'm realizing I think what's going wrong now. Am I crazy? So when they say F then E are pushed on the stack, they don't mean the addresses of F and E. They mean F and E the values. So it says, fortunately, it lets you use CMake nowadays, but I'm not sure you can set everything you need in there. It very shoddily supports CMake, as from my experience. Houdini, or thank you so much for the follow. I'm going to call you Houdini. Howden. I think I know what the issue is. We have the actual... We're pushing the address when we need to be pushing the value. So this is an actual issue with the Microsoft x64 calling convention. Yeah. So if type size of parameter is greater than 8, return false. If it's greater than or equal to 4, return false. Otherwise, return true. Shadow stack stuff. Here's where the juicy bits are. For each argument, if index is greater than or equal to argument register count, break. If arg count is greater than or equal to argument register count, for each putter reversed in arguments, argument putter. This doesn't seem right. Sorry, I wonder what I'm doing here, because I definitely wrote this and it looks bad. Ifidi, even if so, I never bothered to learn CMake. I found premake, which is a little simpler and enough for my use cases. That's fair. You need to type 100 lines of code for just hello world. Just use CMake, lol. I recommend CMake. It's not good, but it's not the worst. So I'm actually altering the pointer. So it says, I'm not sure what you're doing here either. I'm actually altering the pointer within the arguments vector. I don't know why I'm not just doing this. Right? And I want to make that a new thing. Sraid. Just make a CMake template, I'd say. I think they were talking about premake, but you're right. Oh, you're talking to Ifidi, the person that uses premake. CMake is vastly superior to makefiles once you're at least a little bit used to it. The dependency handling is a million times better. Because using other projects that also use CMake is trivial. Yep. So I think this is what I'm meaning to do here. And I'm now seeing the issue. If type size of argument type is greater than 8, see, I can't allocate a copy of it. Okay, so to do, allocating a copy of a static variable argument that is now on the stack. Allocating a copy of a static variable argument on the stack does not work when the type to do pass value of allocated of argument. Yeah, push value of argument onto stack rather than its address in cases where that's needed. Because currently, I think if I printed argument, I do like irf emit maybe. Argument. Right, just print me that. I'd like to see it. Sraid says, oh, I see. Yeah, that makes sense, I think. Legendary. I wish CPP or C have something like cargo. I guess that's fair. I'll probably learn CMake for my next project. Dependencies are not nice with premake. Yeah, dependencies work a lot better. I wish C++ or C have something like cargo. I mean, you can make it. There's nothing stopping you. Ex-egoist, thank you so much for the follow. IRFMit instruction. Did not mean to right click. So there should be like an IR instruction kind of dangling somewhere up here. That doesn't make sense. But if it's in the middle of CodeGen, we're never going to see it. It's probably in the middle of CodeGen before the after lowering thing. Here they are. So it's a truncate and a truncate, U32 and S32. This is so difficult. Why does allocate copy of not work? What are we doing? We insert an allocate. Yes, we insert an allocate, which is a pointer to whatever we have. We store into the allocate the copied value, then we get out of there. Am I looking at the wrong thing? We store, so we do an allocate, we store into it. Store to 24, 23. So we allocate 4 for the thing, and then we store R11D into it, yeah? Into R12 effectively, or whatever. So we are storing 0 at this stack address. This is really difficult. Bit69Dream says, also be right back. I'm going to cargo build my 500 depths for my rectangle rendering project. Kappa. Exactly. Cargo is bad. Molly the Man, honestly, in C, C++ world, you can just use Git submodules for dependency management. He's right. It doesn't matter what build system you use. You can use Git submodules, even make files. -8. So really the problem is that we're pushing an address instead of a value, I'm pretty sure. Because we shouldn't be pushing RBP and subbing 4 like this. Lower type to a pointer because that's how the calls have been altered as well. See, but now it is not like that. If argument is greater than register count or type size of is greater than 8. So I want to, this is so complicated. This is breaking my head. I need to like sub off the stack some amount and then store something there. This is difficult. And then get the offset. So in the function parameters, until you get to here, get the rest of them. And then get that as our stack offset. Okay. So yeah, I think we're getting there. I think the arbitrary integer types are working rather well. It's just the issues with the rest of the code now being exposed because it looks like our x64 calling convention does not properly handle the case where these are ANDed together. Right? It's kind of like this. Now I'm going to say to do handle argument on stack handle argument on stack that is not lowered to a pointer. And now this shouldn't compile. Pog. That's exactly what we wanted, because now it says, hey, we can't actually do this. This program would fail. We're not going to allow this. And that's exactly what we want. We want programs that should not work to not compile. What am I looking at? How am I printing something out? IRFMIT instruction. So I think allocating a copy of something, it actually works. I don't think it's actually becoming that much of an issue, if that makes sense. Yeah, it just becomes an allocate4, which is a pointer to U32, right? I don't think there's anything crazy about that. I am kind of curious if we don't do this to do. Just simply what the actual IR looks like to make sure that we are copying properly. There's a few mem copies that got unrolled in here. Lots of great discussion on build systems and stuff. Submodules aren't always a solution, though. For instance, bundling LLVM as a submodule. Yeah, that might be cursed. It would be a bit absurd because it takes so long to compile. Serrade, yeah, of course, but you also don't need to compile all of LLVM just to poke into it. Imagine using LLVM. I love you, Molly the Man. Exactly. Imagine in 2023. Oh. Though I don't know if you can choose which targets you want your LLVM build to support. Imagine not even being able to configure which targets you're building a compiler for. LLVM moment. I'm just messing. I'm sure you can. So yeah, you can see that the value 21 is stored into the stack address, but then we're just storing this stack address when we should be storing the value at this stack address. I know that's a little confusing, but we need to be actually pushing this value. We need to actually sub from RSP and add after, or somehow, yeah, we need to actually sub from RSP and add after. I think that's the case. Sub from RSP, store the value, yeah. Not all arguments passed on stack are lowered to pointers. Only aggregates. Okay. Just use IPM, Intercept Package Manager, POG name. Okay. We've figured out that bug. I don't feel too bad because it's not my fault. I didn't break things today. It's just they've been broken and I didn't notice, so I don't mind not fixing them today, because I'm glad I noticed them today. So yeah, we don't need to do that. We're doing this just fine, and we don't need to allocate a copy of the thing. Interesting. Fix me. We don't need to allocate a copy, a stack copy here of the passed argument if it itself fits in a register. So basically, we don't need to allocate a copy because we don't actually need this allocated and stored into here. If we look at the code, it makes a little more sense. Instead of pushing RBP and then subbing 8 to get the address of the thing that we stored on the stack, what's actually going to end up happening is that we don't do this allocation even, right? We don't allocate 4 at -8 off the stack pointer. We don't move into it. Nothing like that happens. It just stays in, where is it? EAX? Yeah, EAX. So we have EAX in its thing, and then we'll get all the way down to here, and we will be able to actually, it's kind of weird that we're using EAX. It wouldn't be EAX, right? Because of register allocation, but let's just go with it for now. Instead, we would be pushing EAX and then pushing R11D. Instead of those things. And in that case, it would probably work. I don't know that it would. It says error operand type mismatch for push. That's because this is actually a push double word. Nope. No such instruction, push DEX. Okay. I don't think it... Can you not push 32 bits? If you can't push 32 bits, that's going to really suck. Because we're going to have to, like I said, do like sub 4 off the stack pointer. And then move from like EAX into wherever the stack pointer is right now, right? And R11D. You know, just change the calling convention by hand. That didn't work. I do think this is what the issue is, though. That would definitely be an issue. But yeah, we'll get there. We'll get there. Because I think we're going to have to move to something like this. And then when we do get a pointer, we can just push it like we did before. And then subtract from it. So it's going to either be a push sub or a sub move. It seems like. Okay, well that's good. I'm glad we've discovered something to fix in the MSWin calling convention. In any case, maybe there's some tests for arbitrary ints I could use. That's fine. I think we're good. I can't think of any like test cases I want to make sure work right now. Other than the generic, oh, it works, right? I don't want to get like non-power of 2 things working yet. That's going to be quite complicated to handle. Arithmetic, we're going to have to actually insert like ands and ors and stuff, I believe. We're going to have to do some bitwise stuff because the actual underlying implementation will be a byte multiple. And if we have like 17 bits, then that's going to be obviously in 3 bytes. And then, yeah, it's gonna be rough. We'll think about it. In any case, I think that is a good stopping point for today. I feel like we did a whole bunch of stuff, and we actually got arbitrary integers working, which is POG. So that's a good sign. We can just make sure we do something to show this off. And we can do the simple one of these. 138. POG. 69 plus 69 is 138. We did it. Bit69 stream says 420 stream length, POG. Yes, you know it, you know it. Anosirius says, I can't figure out how to pass an array, so don't feel bad. You can't pass an array in any language except Intercept, pretty much. But yeah, Intercept is kind of one of the only languages that doesn't have like the horrible array to pointer decay that C and C++ have inspired in the world. It does happen, but it's not implicit. So it's not decay at all. I think we can look at like arrays. Yeah. Pretty sure you can in C#. That's possible. I don't honestly know C# that well. I don't think I've ever tried to pass an array in C#. I've passed structs, I've passed numbers, I've passed floats. Yeah, I don't think I've ever tried. Anosir says, can you? Let me check. Awesome. Awesome, awesome. If anyone has any questions, now's a great time. We have implemented arbitrary width integers in Intercept today, a language I made up. What that means is basically I've taken what used to be just the one single integer type of integer, and I've changed that so that we now have, if you type a U followed by a bunch of digits, then you will get actually a type, and that type will be an unsigned or signed integer based on the U or the S, unsigned or signed, and then the number, the digits, right, the number the digits represent will actually be the bit width of that number. So if you're familiar with C, uint16t is like equal to U16, right? And if that doesn't help you, then basically what this means is U16 means we get 16 bits of unsigned integer. And you could also do U27 if you wanted and get 27 bits of unsigned integer, although this is not supported yet. So I think adding to the to-do a miscellaneous and say a little extra thing here and say that properly support arbitrarily sized integer arithmetic, i.e. 18-bit overflow, addition overflow, and such. And I don't know. How can I return the last exit code in Windows? Well, Moldy the Man, it's going to be dependent on what shell you're in. But most of the time, there's an environment variable called last exit code. It might have no spaces, and it might have spaces, depends on your shell, right? But if you just echo the environment variable of last exit code or last exit code, it's one of those, just so you know. That should work for you. Command, I think it's error level. Oh, you are right, Anosirius. You're right. They do this stupid. I think you can also do last exit code in command. Molly the Man says, yeah. Legendary PowerShell $ question mark should work. Not in new shell. Anosirius says, it's not stupid. You like cmd.exe? Or do you like the percentage sign syntax? Which one are you attached to? Halfthor S, Thank you so much for the follow. I appreciate it. And then there's also, yeah, the miscellaneous. I can just add this to the bottom or something. And this is going to be MSWin calling convention. MSWin x64 calling convention needs doesn't properly handle all, just what we're going to say isn't properly handled for non-aggregate arguments on the stack. There we go. And Osiris says, I don't mind percentage. I'm just used to it at this point though. And Osiris says kind of both. Command is limited, but it could be useful if they'd put effort into it. I mean, I agree there. I just think they didn't put effort into it. So I agree it still could be good if they put effort into it, but Microsoft doesn't tend to do what the users want. Bit69Stream says, damn, that's a lot of to-dos. Well, there's a lot to do. There's just so much to do. It's endless. We're going to add this to-do here. Bit69Stream says, fair. But yeah, it's like we do need order-independent types for struct declarations. We do need slices and dynamic arrays and code gen and parsing and blah, blah, blah. We do need to be able to return arrays from functions, which we can't do yet. We can't return any aggregates from functions yet because that's complicated because you have to add in a hidden parameter that the caller then allocates space for, and that's a lot of changes, right? That's a lot of changes. We got all of the attributes that we want to do, discardable, no return, maybe unused, deprecated, call once, etc. It's rough. We got a rough time. By the way, 69 in my nick reads as S. Okay, I can call you Bitstream. I can call you Bitstream. Bit69Stream. Listen. How am I supposed to know, okay? I appreciate you letting me know. Sounds like a SoundCloud rapper name, lol. I do. Don't let broken MSWin calling convention through without erroring. Eventually this won't be an error, and we'll handle this properly. Not yet, though. Bitstream says, lol, I just stole some font name. Okie doke, okie doke. I don't think my example is necessarily helpful for arbitrary ints. Could probably be way better examples. To do arbitrary with non-power of 2. Doing math on non-power of 2 bit width integers would be really useful for modeling hardware as well as bit fields, etc. I think that's fine with integer arithmetic. So to do proper handling of arbitrary with integer arithmetic. Sure. Currently, unsigned would work, just signed wouldn't. Molly the Man, what are you trying to make with this language? I don't think I'm trying to make anything. I know that sounds kind of weird. I have a vision in my head, obviously, but I don't have like a concrete vision. I just kind of make stuff, and I go by feel a lot of the time. What I'm trying to make is something that's like powerful while also being helpful and not like less foot guns but more power. You know what I mean? Like, I don't want to just say, oh, in C, by having pointers, that means that you can dereference null, and that means you have to check for that everywhere, and if you don't, then it's a foot gun and you can easily shoot yourself in the foot by not checking for pointers null. So don't do that. Instead of just saying don't do that and limiting that and saying, you can't do those things C did because it was a foot gun, I'm trying to say, well, we still allow those things. We just make it A, not really needed because there are other solutions in the language, and B, we make it more things possible that aren't memory errors. But that's not like the goal of the language. This is just what I'm thinking about like today. Tomorrow I might wake up and go, I'm gonna write a domain-specific language in Intercept, and I want to start making it like there's no goal. Originally, it was meant to like look like Lisp, and at some points it was even meant to be a Lisp, but it quickly became not that, clearly, as you can tell. But yeah, the point is it should just be a language that works. That's really step one. Bitstream says, right now it reminds me of Jai a bit. That's what people have said for a long time. With those names, type equals value and colon colon. Colon colon was sort of inspired by Jai, and colon colon is the type inference. So it's like whatever this expression, the type of this expression is, that's what the thing on the left will be declared as. Moldy the Man says, yeah, it's like Jai. Here's the thing, Jai has a very specific, like, goal, right? Jai is meant to be like a game development language. It's meant to be easy to develop games, which means that things like graphics and stuff like that is like built into Jai, or at least built into the standard library. And that's not the point of Intercept. Intercept is meant as a programming language, a general purpose programming language, where you can do like, you can write Rule 110 in it, or you can write a graphics program. You know what I mean? It's like that. How can you make int number equals 10 in int? I think the for loop would be good for that. Like that. Programming pog. Honestly, I think you could probably make like little pins, just like pogs, but for programming languages. Moldy the Man says, cool. I'm glad. And technically int is, right? So you're saying number is an int, which is assigned 32 equals to 10. And Osiris says, oh yeah, you can pass arrays in C#, by the way. That's cool. We can as well. Intercept is just C#, confirmed. But yeah, you can pass arrays like this to a function, totally fine, totally allowed. And you can also pass references to arrays. So you can have a reference to an integer array of 4 integers, and then you can pass that, and you'll actually be able to modify the referenced array from within this function, and then after this returns, it'll be modified. And Osiris, I want to trust you so bad, but I haven't seen that link before, and I don't know what that website is. You need to make some project with int at some point. I mean, yeah, that's the goal. There's a lot of projects that need to happen within int at some point, right? There needs to be a standard library for Intercept. That's going to be a whole thing. Bitstream says, yeah, like a calculator. We can already do that. We can already write a calculator. That's so easy. I mean, I've already wrote like rule 110, the SDL example. You know, I'm writing stuff. You should write stuff too. Make a PR submitting some new examples that help us out. That'd be cool. So much IR. Here it is. But yeah, here's rule 110. That's in the repository. That's in there. And Osiris now links a paste bin. Okay. You have ransomware. You have ransomware now, by the way. No! I've been hacked. A guest has hacked me. The hacker known as A Guest. Oh. And Osiris says, oh dear, that's cool. Hacked. Using system console app run program main for each int I and I. So this is a dynamic int array. That's returning it. This is something different than we were talking about. But this is a dynamic array. Can you do a fixed size array? You can pass arrays in JavaScript, superior language. Lamau. Oh, damn, I can't believe I have ransomware now. Cool. Yeah, so we've got a small problem with the x64 calling convention. We did diagnose that. We still need constness. There's an SDL3 now. Okay, SDL3 is out. That's cool. That's very cool. Okay, yeah. Where are we? How are we doing? Who's here? Jorgegon. That's a good name, Jorgegon. The code for that is here. Currently, apart from plain text, only C++ and... I know what is under here. Are supported because I'm writing a paper about those. That's right, that's right. I'm excited for this. I'm going to add Intercept to this. I don't think it's actually done in that crazy of a way. I think it'd be doable. Yeah. Yeah, see? Easy. Just add some keywords, add some params. It'll be good. But yeah, we have a lot to do. We have a lot to do. Speaking of, another thing that we have a lot to do was, I think we can't use this as an L value yet. Can we? I don't know if I fixed this. // What am I, a nerd? It's semicolon for a comment, bud. Okay, Pog, that works. We can now write that much simpler. How about that? How about that? Did I change this? Oh, I don't need to. Yeah. Cool. Compiler in JavaScript, no enums dynamically typed? That sounds the worst thing in the world. Mr. Mugame, easy. SDL3 is a thing? That's what I was just wondering. Apparently SDL3 is out. Or they're working on it? Yeah, yeah. Apparently since like 8 months ago, but I didn't know about this. Cool. So apparently we're at pre-release 3.0. Did you see that? That's crazy. crazy. SDL3 is happening. Oh, I'm so excited, Valve. Valve, please fix. Please fix. No, seriously, shake my head, this works. Talking about language server in LaTeX? As far as I know, SDL3 is already being developed. Yep, you're right, Bitstream. The .sty is the hard part. The C++ is just Aho Korosik. The .sty. Is that like, oh yeah, I forgot it's like declarative. Yeah. This is the triple backticks and stuff, right? Oh, this is terrifying. Yep, triple backtick starts a code block. You are a master at LaTeX. This looks terrifying, I will say. I can't wait to make a PR and add Intercept to this. And Osiris gives another paste bin. I don't think... This is still a dynamic array, as you can see. And also, you're not passing it as a parameter. So, like, can you have an integer array size 3 as a parameter here, or as a return value? Or does it have to be dynamic or a slice? Mr. Mugame says, no, it was an idea / question if someone has done this. Lol. Has been done? Question mark? Okay, well, cool. We got this working. By the way, did you know I'm really not smart? This is not how this should be structured at all. In case you're curious. Do you know what a way better structure is instead of splitting 3 bits out? I should have just said bits is an integer equal to state and 7 to the left index minus 1. It won't let you do static int3 foo, it errors out. How can you return from a function in int? Have it be the last expression in the function body. But yeah, I should have just done this and gotten all the bits, and then said if bits is equal to ob000, if bits is equal to ob001. You know what I mean? How this is so much easier to understand than anything that this horrible tree of sadness is? Why did I write it like this, chat? Who let me do this? This is so much more understandable. It's crazy what I've done here. Bitstream says, bits? Did somebody call me? Lol. Houdin, lol. Anosirius, uh-oh. So sometimes the most straightforward solution is not the best one. That's true. But whatever I've done here, it's not right. It is not right. I did all my husband's Java homework when he was in college. I'm so sorry. My condolences. Java, huh? I still can't. I'm still baffled at why I did it this way. We have binary integer literals. Like, we have ob000 as an integer literal. Why did I feel the need to split this into 3 basically booleans? I really don't get it. And then here's the interesting thing, is that, like, I have to check if it's greater than 0, because I'm not actually I'm not setting it to 1 if this is not 0, which would have been like, if I am going to do it this way, I should have put equals 0. That way this is either 0 or 1, and it's 1 if and only if this was 1. But I just didn't do that either. I was like, yeah, you know what, just give me, like, give me the value 8. Give me mbit as 8, that'll be helpful. Sorry, Lenzer invents bulls from scratch, 2022 colorized. This is literally that. I just really don't get why I didn't do this. Right? Like this is just what I should have done. And then I need to shift all of this to the right. This is why I didn't do it, because I didn't shift it to the right by index -1, basically, right? Yeah, because these 3 ones, yeah, there you go. This is what I should have done. And then I can just do if bits. If bits equals 0, 0, new state is equal to new state, or 1 to the left index. Not complicated. Right? This is all it should have been. Also, this is 0, 0, 1. 0, 0, 0, I need to do actually the not 1 to the left index, and it. 0, 0, 0, new state and not 1 left index. 0, 0, 1, new state or 1 left index. And then I can just continue these all the way up, yeah? Why did I do it in this horrible way? If bits equals 0, 1, 0. 0, 1, 0 or 0, 1, 1 both result in adding a 1 at this spot. We don't have OR yet, logical OR, which kind of sucks. But it just means we have to do if bits equals blah, do a 1. And then just these 3, except this first one is set to a 1. And I think these are different. So 1, 0, 0, and not 1, 0, 1, set, 1, 1, 1, not 1, 1, 0, set. So this, we need to not, 1, 1, 0, we need to set. Okay, that should be that. And this is 1, 1, 0. Because as you can see, if you clear a bit, set a bit, set a bit, clear a bit, set a bit, set a bit, set a bit, clear a bit, that's 110 in binary. And then we don't need to do all this crazy branching nonsense, right? I think this isn't unreasonable. Can I do else if? Is that gonna, I think this should be fine. Why is else not working? Because that's not being treated as one thing. I think it should still work even without that, should it not? I think it should be fine. Should it be else if? I'm pretty sure it wouldn't matter because none of these conditions can actually happen at the same time. Bits cannot equal 0 and 1 at the same time. Know what I mean? Well, it compiled. And it still worked. Pog. Ain't that more understandable? What this should be is a switch case conned whatever. Yeah. It should say, based on bits, return a different value to new state. It should be something like this. I don't know if this is the syntax, but basically we're going to switch on bits, right? And then say something like that. Yeah, but for now this is fine. Checking equality with a single equals. You know it. I thought I was such elite little hacker using do-whiles and switches in my first programming class, lol. The highest level. Using the highest level things in your programming class. In C, really. The highest level loops. You're like, oh man, I'm such a hacker. But yeah, I think this should be fine. Everything still works, so... That's Pog. And this should definitely cut down on the... There's just a bunch of basic blocks that are empty. This can't be good, can it? Sorry, it says, I mean, we can implement switch right now. You just have to emit it like an else if chain internally. Yeah, like this. Or as a jump table, or as, you know. Don't need switch if my Vim can yank. I don't know why, but I really like that. Those blocks, I think, are the end blocks of all the nested ifs. Oh yeah, the join block of this if is going to be where the else would be, which is nowhere. Okay. Yeah. Okay. So is this literally, I just have to look at the code then. Is there literally like 10 branches in a row? Yeah, there is. This is an interesting case. Jump L30. Jump L31. Jump L30. Jump L30. Jump L30. This is actually just a single if whose else contains an if and so on. Exactly. And that's why we get this horrible code gen. I did ask if you could do a go-to statement in C# and got to learn methods 2 weeks early though. Lol. So I am pretty elite. That's true. This is so much better to understand though. I'm gonna push this. Simplify rule 110. Tree of Sadness has been replaced by knockoff switch statement. We can actually use if to return a value into an argument. Conditionally, to return different values into an argument conditionally. Okay. Saraid says, interestingly, this is also why in languages that have endif, elif is actually at least parsed differently, because if you don't do that, you get like 10 endifs in a row just like here. Yep, that's actually exactly correct. Poggers, poggers, poggers. Because an endif, an elif is basically an else endif. Right? Elif x is actually equal to else endif, else x endif. As far as I know. Can't you just do new state is equal to if because because if is an expression? That'd also be quite the test for our phi node code gen. I'd have to put an else, I guess, right? I don't think that would work because I'd have to put an else to each one of these. Because those are 0 through 7. And that's all the values that 3 bits can have. I lost you there, Saraid. I don't know where you're going with this. So you can replace the last else with an else. That's not the issue. That's not the issue. Because right, there is actually an if else. This else if chain is exhaustive. So technically, if we try and think about this, we have an else like this, and then if bits, right? And then we have else, if bits, else, blah, blah, blah. So the only one that doesn't have an else would be this one at the end, right? So if we just made this not an if, right? then you're saying this if has an else, this if has an else, this if has an else, etc., which makes this able to return a value as an if statement, which means that we can do new state is equal to this, right? Is this what you're saying? I don't think this is going to work. There you go. Remove new state or equals from all the nested ifs. Oh, that's a good point. Why did that not work? What the? Okay, it did code gen and it needs a lot of registers, Saraid. We don't have this down yet. All right, add this to the tests. What, just this thing? Hopefully you're gonna fix that one. I don't know if I'm gonna be able to fix this one. All of it. Why would I add all of it to the tests? That doesn't make sense, does it? That's a test for the RA. Lots of phi nodes. So is there a reason this isn't fine? Like this tests the RA, right? Or are you saying that this might not fail in the same way? New state isn't defined, bits isn't defined. I mean, bits is defined, new state is now defined. We can actually just do this. Index isn't defined. I just add the entire thing. It seems crazy complicated. You might be right that it's easier. I'm gonna see if this fails in the same way. If it doesn't, I'll just add the whole thing. It just seems kind of crazy to me to have all of those things. That just gets us a seg fault. Okay, well, we tried. Also, new state is going to be an integer before this. That might be the issue. Yeah, and it didn't cause the RA to overflow. So we'll just do the whole thing. Lots of phi nodes. One of the biggest issues is that this should return 0 and copying the entire thing takes 5 seconds. This is taking much longer. I wasn't worried about how long it takes. Why did that not work? How did we just get rid of main somehow? What? Okay, there we go. Maybe I'm crazy. Maybe it worked. Okay. Yeah. Did I don't know if I even already did this. I'm just gonna do it. I'm not smart. So we have 0, and then we're supposed to have a bunch of things, which is meant to be, what is it? Yeah, so we can do this, and then do new state is assigned to a new thing. And then add 2. Yeah. And then hopefully this one actually works, because I need this thing to go here. There we go. So now this is the thing that we should get after a 0 status code. We don't really care about the printout. It's true, but the test will fail if that isn't there, even if it's working. That's not really helpful to anybody now. Now we have rule 110, Phantasmo. And then we should be able to see all right, that looks good. That looks good. Everything's going well. See if optimizing it helps. All right, all right. It did not make a difference. We can optimize, and we still are left with all these phi nodes. No help for us. I'm pretty sure this one is just a bug, by the way. There is a phi node here. 106. It's just the top of the screen bug. But yeah, there we go. We tried it. Anyways, we solved a bunch of bugs at the end of the stream. That's good. And we also, yeah, that went well. We now have arbitrary integer types. Also, Yoink2000, thank you so much for the follow. But yeah, we now have arbitrary integer size types in our language Intercept. And you can even do arithmetic on them if you would like. You can do a lot of stuff. So yeah, that's good, that's good. You can do all sorts of things in this language. We have an SDL2 example that is working somewhat. We have an SDL2 example. We have Rule 110, if you're interested in anything like that, seeing that happen. We've got the Rule 110, okay? We got the Rule 110. Eat the work, yeah? So yeah, this is doing good. We are having tons of fun, and the language is going well. We still have some more stuff to do in that we need to have some x64 calling convention stuff fixed, because apparently I implemented that wrong. But that's okay, we can deal with that next time around. And then we also want to support like 18-bit addition overflow, right? So if we have arbitrarily sized integers, we also want arbitrarily sized integer arithmetic. That way we can take a signed integer that's 18 bits, and then if it happens to go negative, the 18th or the 17th bit is set in that number, meaning it's negative, and it actually will work and happen through arithmetic, rather than the sign bit being being incorrect, right? And this may be like per backend. I don't know how this is going to happen, but it's gonna. We also need early return. We still haven't done that. So the return keyword we do not have, right? We just don't have return. So having return would be something that I think is a major advantage in structuring things. Obviously, you don't need it a lot of the time. There's no real reason that would be necessary, right? but it does help to do this. Story says, also I'm going to add a README to the LaTeX thing later to make sure you actually know how to use this thing if you want to add Intercept support. That's a good idea. That's a good idea. Because I think that would really help in writing like the tutorial and stuff and the reference. Because it's all written in LaTeX, so, and we have a lot of code blocks and things like that. And it'd be great if I didn't have to do some crazy verbatim blocks like this with same page, or I think we use pigments or something. Or listings, I can't remember. We use something to actually highlight things. But yeah, it's a mess. It's gonna help a lot, I feel like. And it's just gonna be fun to work on that. I like working on little tools that help in that way. So yeah, anyways, thank you all so much for watching. Our language is coming along very nicely. Be sure to check out the Discord, join it. You will get announcements every time I go live, especially if you ask for the notifs group. You will be pinged. You will never miss another stream. This has been the 52nd part of the compiler. First time chat, Samerkin, thank you so much for the follow. Samerkin says thanks. Bitstream says bye. Mr. Mugame says bye-bye. But yeah, go check out the Discord, check out the YouTube down below. It has every single VOD that I have ever streamed. Can I go to YouTube channel? I can probably go to youtube.com/@Linzer. And you get here, perfect. And you go to my YouTube channel, there's all sorts of things, as you can see, all 51 parts of the compiler for fun is up there, and they're all there for you to enjoy. Ain't that fun? Yeah, be sure to check it out. Check out the YouTube, check out the GitHub and Codeberg links to actually see all these projects, fork them yourself, make some changes, maybe compile them yourself and see how they work. It'd be fun. I have an OS, I work on that sometimes. I have a text editor, I work on that sometimes. I have like a floating point library and software that I started working on recently just for fun. That's been fun figuring out how to multiply floating point numbers by hand. And it's actually really rough, but it's a lot of fun. I do all these things. I show them to you in hopes that you enjoy them, and I hope that you have today. Bitstream says, notifs me, senpai. You got it. Bitstream is in notifs. Oh, poggers. Negative infinity plus infinity equals nan. Yeah, exactly. I'm also going to put a screenshot of the generated LaTeX code in code review real quick. Oh, yes. Naturally. You have penalty doubleism, Burke failure, box void protect penalty during under box void protect penalty. Feel like I'm beatboxing. This is what LaTeX outputs if you ask it to write some verbatim-ish code to a file. Oh no. That's so terrible. That's not even what you're generating. That's just what LaTeX does naturally. That's so messy. So much better. You're gonna revolutionize LaTeX, alright, I promise. But yeah, be sure to check out all the links, do the buttons, click the things, and if you would like, you know, just hang out. Hang out, check out the Discord, and have a fun time. Because we like having fun times. And doing maths. But yeah, that's it. We implemented arbitrary sized integers, we found some bugs, we fixed some bugs, we're doing good. I'll be here probably tomorrow or the Wednesday, it depends, but not Tuesday. That's an update from me, and yeah, I hope you all have a great day. Program some amazing things, because I know you're capable of it. I'll see you next time in this epic soldering session. Oh, pog. I'll see you next time, guys. Bye!